Morning, all participants. I am Ullas Degodwar, Secretary Roads, PWD Government of Maharashtra. We all are intellects and we all know the Indians are very creative, and this COVID has given us an opportunity to think in different directions. Let us see how do we work on this. You see, this picture is very much self-speaking and has created imbalance in the society. Laborers are migrating reversely. So at one place, there is increase in the labor than the requirement, and at other place, there is requirement of the laborers and they are not available. So this is a typical situations which we are facing in India. Next. So my presentation will be covering part of some introduction for the infrastructure, then the current COVID situation, and how do we recover in the infrastructure segment post pandemic. See, the infrastructure development is a prerequisite for the development of any country. We all know. I did not repeat it. The projects can be greenfield projects or the upgrading of the new projects. You see, India is such a country having different climatic conditions, different geographical conditions. We have got huge road network. It's about 3.3 billion kilometers. And private sector is emerging as a key player in the infrastructure segment. So these are the various infrastructure development that are taking place in India. So you can just see the quantum of national infrastructure pipeline. It is 111 lakh crores of rupees. And the infrastructure, particularly energy, roads, railways, and urban projects, these will be about 70% of that. And the component of the central government will be 39% and state government will be 13%. So, just this can give you the huge potential in the infrastructure field. The policy and vision document was published in December 19, the National Infrastructure Pipeline Policy, NIP, that is 111 trillion of Indian rupees. And the success of this NIP will be depending on these three critical factors, that is human capital, innovative funding models, and greater technological integration. So naturally, all of us will be required to focus on these areas and come out with the different alternatives and options. You see, if we consider the Indian economy, the agriculture is the first, and the second largest one is the construction industry. The size is about 10.5 trillion Indian rupees, and it employs the 8% of the GDP. That's 57.5 million people. Just see this thing, the quantum. I think most of the countries will be having less than this population. Now, what we need to consider is the impact of COVID on our infrastructure projects, where we are required to take few more precautions. Those were not obligatory in the pre-COVID scenes. So, the COVID coronavirus has created a turmoil in the construction industry, and the effect is reduction in both supply and demand. So the social distancing, PPE, hygiene, it is going to drive up the project cost in the short term. Not in long term, but in short term, till everybody gets established himself. Naturally, it's going to add to the extra interest cost on the working capital loans. We feel that it is going to add to the extent of maybe 20% or 25% for the workers, and overall the semi-skilled workers maybe 10 to 15%. So this has to be taken into account whenever we are doing the future projects. The infrastructure projects are hit because of the uncertainty labor shortage, as I have explained in my first slide itself. Then increase the manpower charges, reduction of the business, loss of income, then effect on the allocation of the government funds. So this is adding to the indirect costs. So these are the impacts that we all of us. Now, the construction sector is the basic requirement for the construction human beings, and that has got a big impact. So naturally, the inflation will be there, the construction will get costly. And as per the guidelines, we have to use the masks and sanitizers, which will be mandatory after removal of the lockdown. So each one in the construction industry has to take into account these factors. You see, another effect, the aspect that we need to consider is the insurance of the masons and the workers, scarcity of the laborers. So this will be added cost in our projects. Now, what needs to be done? You see, on one side, there is additional cost that is involved. On the other side, we have to search for alternative mechanisms also. As the time goes, we will be discussing on those aspects also. What needs to be done? Let us see. Now, we have to quickly devise the ways to keep the masses employed, enhance the quality of living, and most important is to meet the project timelines and budgets. On one side, there is scarcity of the manpower, increasing the manpower cost. On the other side, we have to meet the timelines. How to balance these is the issue of discussion today. Now, naturally, all participants will be expecting to listen something from our end. What government is doing to support the industry, contractors, labor sector, and overall economy? Definitely, I will be giving few listed examples what government is doing. But here we have to keep in mind that the government, developers, and contractors have to play collectively the respective roles, and then we will be able to come out with good solutions. Now, what trust needs to be given by all of us? One, building future ready works. Intelligent, resilient, and sustainable infrastructure is the basic requirement. Then we have to provide employment also. The most important thing is to revive the confidence of the private sector. That is what is needed to be done by the government. Then, better urban planning and design will be required by the ULBs. Strengthening of the rural infrastructure to promote growth of agro-based industries, that is basically in India. Then, understanding the criticality of the road network and related infrastructure for business continuity has to be thought of. So, we all know the Atmanirbhar Bharat Abhiyan of 20 trillion Indian rupees has been declared by the government of India, where the prioritization of MSMEs, liquidity welfare, agriculture, power distribution, mining, health, housing, rural employment, all these things have been considered in that. So I will appeal all the participants to go through this package and try to take advantage to the extent possible and to generate the confidence in our people and our colleagues to make best use of this pandemic situation, which we should take it as now an opportunity. Now, we slightly focus on the areas where the technology can be helpful for the fighting the COVID situation. There are many ways. You see, worst hit sector is the construction sector. We all know they were required to shut down their sites to protect their workers. On sites, they are still running, but they have to take extra precautions of social distancing, staggered work schedules, hygiene measures, and all those things. Now, we can think of more use of the drone. It's not only for the purpose of the marriage ceremonies. Now, drone can be used as a very effective alternative mode of the infrastructure developments where the close contacts of the human elements can be avoided, further it can be replaced. Then we can think of a lot of things which enable the interaction of uniquely identifiable computing devices. So we have to increase the use of IoTs. You see, private sector is already making use of that. Most of the participants are from the private sector. They will say that we all know it. But when I am discussing with you, I am talking with myself, my colleagues in the government also, to increase the use of the IoTs. See, the IoT comes with the features like remote access, office to field data exchange, cloud computing, data storage, and sensors. So all these things, real-time data about the site and workforce you can get out of that. So we have to make better and more use of these technologies. ERP platform that consolidate different functions, including accounting, job posting, human resources, inventory management, and it acts as a centralized hub for a firm's vital data. So we are going to promote this in the government as well as whatever use we are doing in the private, we can increase it further. Then we can think of the automated workflow tools, use of the software and technology, digitalization, automation of routine processes. These are some of the things that we can definitely uh, uh, use more and more in the future, and we can face the pandemic situation in a better way. I think. Then digitalizing everything, document imaging. You see, this is one of the most important factor in our government offices. Wherever you visit any government office, you will find the heap of the files and the person is lost in those files. So digitalization in the government is very important thing that we are going to start from our side, and I'm sharing this with you. The different types of technology facility management has come up to maintain the hygiene. UV disinfection is there, the agent cleaning is there, fumigation is there. So sanitization and safe place to work and operate. So these are not the things just to tell each other, but it's important to really implement that on the site, which is, I'm sure, if after my lecture, even 20% of the participants decide that I'm going to implement this on my site, I'm sure the purpose of this talk is served. It's my appeal to all. Video conferencing. Already in the governments, we have stopped all the physical meetings. We are taking our meetings on the video conferencing. Private sector is already working on that. So this is one of the area where the higher top bosses of the management are using it. But what needs to be done is to expand it to the middle level and lower level also. That is what I think is important for all of us. Now you all may be thinking that okay, I have shared many of the things, what needs to be done, what we should think of, how to make use of the technology. So the participants may be interested in knowing what really government has done in the areas for giving the reliefs to the infrastructure sector. I'm going to share briefly those aspects also. Just see it. You see, the central government and the state government has issued various guidelines, and those are issued every day and week. The moment we come across some representation from the construction industry, from our contractors association, we are doing the brainstorming among the government, thinking the pros and cons of the demands placed by them, and coming out of the solution to which will be useful, which will be helpful to the infrastructure segment, as well as the government interest will also be protected to some extent. So the balancing these two things are being done. The government issued circular on 29th of July 20, then 14th of October 20, then further circular will be issued in this week also. Say for example, the giving the extension of the time limits for the various contracts. We have already given extension of 6 months to all the contracts. We will think about that in future also. For the performance of the contracts, we are keeping the provisions of the security deposit, and for the below tenders, we are providing the provisions of the additional security deposit. This amount is lying with the government. Here, uh, to give some relaxation, we are returning the security deposits to them. We are thinking of doing further relaxations in the security deposit and additional security deposits. So these are some of the measures that we have taken. The participants can talk within their organization and suggest their government to think on these lines with their respective governments. So this is what we have done. Then escalation clause will be applicable as per the tender conditions. That notification is also given by us. Then we are thinking of recovering the security deposit amounts through the bills and even through the balance amount where the payments are not made to the contractors. We are going to recover the security deposit through those pending bills also. Then reducing the amount of security deposit from 10% to 3%, 2%, 1%, and like that. Then returning that immediately after work is completed, or returning that before the defectability period to some extent. So these are some of the measures that we're taking. We are putting some condition of the time limit also in that, and we're going to think of the change in these timelines in the days to come. These are some of the relief that we have given for the additional performance security for works costing more than 50 lakhs of rupees. So these are some of the relief that we are giving on behalf of Government of Maharashtra. We have to protect the government interest also. We have to think from all the sides. So naturally, what we have put the condition is that the force majeure clause will not be applicable where we are availing the facility of getting the extension of 6 months. Now, validity of these guidelines we have kept to 31st of March 2022. These times will keep on changing. Then we have delegated the powers to the lower officers for faster implementation of these concessions that we're giving, so that the decision making process will ease further, the paperwork and correspondence will be reduced. We have adapted few more measures. Say for example, we are not going to take up the new works immediately. Why? Because you see, unless we complete the incomplete asset, it can't be put into the public use. And whatever investment is there in that asset creation remains idle for a longer period. So, as a policy, what we have decided that we will finish off our works in progress in the first stage, and then subsequently we will think of the works which are not started. So the priorities of 1, 2, 3, 4, so roads, bridges, buildings, incomplete work, the position, the difficulties at the site, how that can be put into the use. These are different elements that we are considering. Why I'm sharing these things with the participants? Because you see, the participants are all across the globe. I know many of them from the private sector, few of them maybe from the government sector. Their governments might be thinking in these directions. They might have taken even better decisions. They can share those decisions during our discussions, and where it has not been initiated, they can get a glimpse of this. They can follow these guidelines, and they can insist their top management bosses to take the decisions in these lines. So that is basically the purpose of sharing these various aspects with all the participants, dignitaries. Further, we are thinking to revise the contract clauses with this pandemic situation. So if these kind of situations come in the future, what should be our force majeure clause, what needs to be done in that. So in order to avoid the disputes in future, so we are thinking on those lines also. If somebody has worked on that, I will welcome such participant to share his views with us. Now we will think something more in addition to what we have discussed so far. Now what we need to do is think of design, manufacture and assembly. These things are focusing the precast construction. In the construction industries, particularly multi-story buildings and repetitive structures, this is used by the private sector. What needs to be done is to make it further easy to go up to the district places, taluka places, and the way we have created many things like using the fly ash. With very small units, we are using the precast units of fly ash. Something like that. A small model needs to be developed, which should be felt easy for a small contractor, for a small person in the infrastructure segment. Yes, it is doable for me. It is something challenging for all of us. And I appeal someone to come forward, and I will welcome if somebody might have shared or might be sharing on this aspect. It will be very much welcome step. Prefab. It is just synonym that I am sharing with you, because it increases the productivity, it improves the safety and leads to disruption and many of the things. So prefab constructions, what we are doing is now we are going to add these elements in our schedule of rates. We have already initiated that action, so that once it comes in the schedule of rates of the states, these are used by the different departments within the government, and naturally after a period of maybe 3 to 4 years, we find that it has become an usual practice amongst the industry. Modular construction technique, again similar thing which we have discussed. We are following some of the things from our National Highway Authority of India. They have digitally transformed itself, moving to online project management workflows. Then multiple command control centers they have created, and the smart city projects are swiftly converted into the COVID war rooms at different places. So as a government, we are taking initiatives to put ourselves into these shoes and go ahead. That is what we are trying to do. This might have happened down the line after 4 to 5 years, but the COVID has brought all these things in a compact way to quickly think of them on this and go ahead. So this is the opportunity that has been given by COVID to all of us. Now, what can be the view post-pandemic of our construction sites? You see, it has to be cleaner, less crowded, then regular employee temperature checks, disinfection of sites, tools, machinery, social distancing, 100% mask, gloves policy. You might be saying, yeah, yes, all these things are known to us. You are repeatedly telling this, but why I'm repeating is many times. You see, we all talk about the tree plantation a lot. Just think yourself, how many trees you yourself have really planted? Answer is known to each one of us. I don't say that everyone will agree with this. Definitely, barring few good examples, this is what happens with all of us. We talk a lot about this, but when it comes to the implementation, we are lethargic on that. What I want to insist on is to be very vigilant on this. Whenever you are talking with your subordinate, it should start with these things. You must open your talk with this. You should close your talk with this. Then that will lead the importance of these things to your subordinates, and then when they will be teaching and discussing with them, slowly, it will leave the impact on them. So I appeal all of you to think, talk continuously on this. Social distancing is needed for some more time, maybe another 6 months or so. So till this health crisis is over, we need to be done on this. The effect of this pandemic situation is extended project spans is there. So whenever there is extension in the time limit, naturally all the workflows are to be rearranged. It has to be done in a very systematic way. So all this exercise needs to be done. Then offset construction techniques will have to be adopted by all of us. That is prefab, as I have told you earlier, using the different techniques, then use of the IT solutions. These are some of the things that we need to keep in the mind. So, in all, what I wanted to share with all of you is to just focus on few important elements. That is the safety of the workers. Secondly, revising the timelines in the most efficient way. Thirdly, cooperating with the governments, coming out with the innovative solutions, sharing these innovative solutions amongst our groups. Mr. Manjrekar has taken a very good step to keep this workshop for 5 days, and he has tried to bring so many uh, alumni and the dignitaries on one platform and share the views of each other. I welcome this step of Mr. Manjrekar, and I welcome my
To all. I'm very honored to participate in India Construction Week 2020. I will be speaking to you today about the Panama construction sector pandemic experience. Our presentation will include a brief introduction, then we will talk about the industry lockdown, followed by a transition towards restart, and we will end with the beginning of our restart. Before we get started with the presentation, I would like to take a few minutes to tell you where we're located. Panama is in Central America, as you can see, in the Western Hemisphere, a good distance from where you're located in India. Panama is the last country of the northern North America continent which joins South America. Panama has a peculiarity in that it is located in a horizontal position. As you can see, we have our neighbors. Costa Rica is to our west and Colombia is to our east. And so we have the Pacific Ocean on the south and the Caribbean on the north. In this map, you can see a divide in the middle of the country, which is the Panama Canal. We're a small country, 75,000 square kilometers, with a population of only 4.2 million people and a GDP of 73.4 billion, which was estimated for 2020. Of course, that's before the pandemic. The effect of the pandemic in time we can see in this presentation. We all know that the pandemic was declared in March, and a few days after it was declared, we had a full construction industry lockdown. Then we had a couple of months where the government had to work hard to set up safety protocols in order for the economy to get started again. We were allowed to do a partial opening for the public sector in early June. However, the private sector was not allowed to start any activity until the middle of September. So this is a timeline that we will be talking about and working with. The start of the lockdown was very quick. As you can see, on March 8th, we had our first case of COVID-19 confirmed in Panama in a local high school. 2 days later, we had our first death reported in Panama from a high school professor. On March 11th, the World Health Organization officially declares a global pandemic, and then on March 13th, the government declared a national state of emergency. On March 19th, health measures restrictions are implemented according to economic sectors by the government of Panama to minimize spread of COVID-19. And on March 25th, construction sector is totally paralyzed with a full lockdown only 17 days after the first confirmed case in Panama. Following the lockdown, there are a series of measures implemented by the government. First, there was the creation of a cabinet-level task force to oversee all pandemic-related issues, including cabinet members from the health, security, education, labor, commerce, agriculture, social development, and social security. And then we had school closures at all levels, including public and private. There was also the establishment of epidemiological containment areas. There was a prohibition of access to mass gatherings like beaches, rivers, sporting events, casinos, churches, any event that had more than 10 people. All foreign flights were restricted from entering Panama, and our international airport was shut down. In addition, testing protocols were developed and initiated, including contact tracing. Hospital capacity, equipment, and personnel were incremented. Development of temporary use field hospitals and hotels used as hospitals to take in mid-level patients. We had key pandemic indicators established and reported, and this was done on a daily basis through community communications. We also had implementation of strict curfews, and we also had liquor sales were banned. Additional measures implemented by the government that lockdown included individual circulation was restricted by gender and hours according to a national ID. Labor contracts and employer obligations furloughs were implemented. Financial obligation furloughs were also implemented. Community outreach via food and monetary support according to need was distributed by the government. Following all of these actions by the government which control the lockdown, we initiated a transition period where basically the economy needed to be reactivated under certain rules and guidelines. So upon closure of the economy, weekly meetings were established between high-level government officials and the private sector, including the Panama Construction Chamber, to develop a plan for restart. These meetings took more than 2 months to develop a guideline. So on May 11th, the Panama government announces these guidelines to be followed by the private sector in order to restart activities with COVID-19 considerations. Extensive development of virtual platforms was required by the government institutions at all levels, with training provided for elaboration of biosecurity or safety protocols in order to safely restart operations. Then on June 1st, authorities allow restart of selected public construction activities, gradually increasing in number, prioritized according to required use. Example, hospitals, food supply projects, transportation projects, any projects that were deemed high priority in order for the economy to get reactivated. Once the public sector projects got started and slowly our industry began to move, on September 7th, the Panama construction sector are allowed to restart gradually following all the biosecurity or safety protocols for COVID-19 prevention as established by the government. These would include establishment of safety committees per work location to include office and field representatives. We also had COVID-19 testing of all workers. We had physical distancing enforced greater than 2 meters between individual workers, mandatory use of breathing protection, frequent hand washing, symptom monitoring and tracing, and medical support on call. These were some of the regulations that were required in order for any project to get started on the private sector as well as the public sector. In this slide, we show a few of the pictures from several job locations. Initially, we did the antigen testing where workers were required to do COVID-19 testing and follow-up testing on restart of work activities. Also, the symptom monitoring and distancing, which was carried out when arriving at work as well as during the work progress or work shifts. Constant hand washing has been promoted through educational campaigns of COVID-19 awareness in order to avoid COVID-19 dissemination. And finally, the Ministry of Health and Ministry of Labor and the media constantly demand reporting and follow-up of COVID-19 procedures and results. Our restart has been very slow, and we have challenges ahead of us. Currently, only 30% of the before COVID activity has been able to restart. The construction sector has assumed significant costs related to per worker expenses to meet all safety protocol requirements. The public sector financing has been very slow to initiate projects. Infusion of public sector capital in the form of outstanding debt payment has not been addressed. Private sector investments and restart are hesitating as the economy is projected to have a 40% drop in GDP in 2020. Finally, labor contract furloughs expire on 31 December 2020, creating, unfortunately, some labor uncertainty and potential unrest for 2021. These are important challenges that we face in our construction industry because of this pandemic that we are all facing in all our countries. With that, I thank you very much for your time and interest. We have to all work together to get back on track, to put our economies to work, to be able to reconstruct our construction industry. So thank you again, and I'll be happy to answer any questions. I have my email. I can answer them by email or
Good morning, everyone. So let me introduce myself. I am Dr. Guillermo Huaco from Lima, Peru. So what I'm gonna present today, so is a word that I started at Texas, United States, when I was doing my PhD, and later on at my home country in Peru, where I am a professor at National University of Engineering. Um, gonna present a rapid structural strengthening for all facilities that can work as a hospitals or healthcare buildings. Let me say thank you to Dr. Surendra Mankrekar, ACI honorary member, who was very kind for his invitation to me. I am very happy to participate in the India Construction Week for this important event, reviving the construction industry in post-COVID world, especially at this time that all the world is in danger. Well, so as we may know, Peru is one of the countries that is very in danger for COVID. So this pandemic hit it to us too strong, quite strong. So, and one of the reason is not only the virus. It's not because we don't have vaccine yet. So one of the important reasons is that we don't have enough healthcare facilities, and this is a politic problem from several past administration from or since 30 years ago. So our current facilities are in poor conditions, or also are all buildings, as you can see on the figures. So and also on the news. So we people who spend hours uh, outside the hospital to be treated by medics and also nurses, and many of them couldn't make it, and for sad they die on the street, as you can see in the figure. So we are now using everyone mask. So you see the figure here above. So sorry, below, which means Peru be strong, Peru resist. As I said, our facilities, the most of them, more than 90% of them, are old. So I am presenting a 60 years public health facility. This is a hospital in Lima, in the capital, in one of the in one of the uptown in Lima, one nearby. So the fancy area of the capital of Peru, called Miraflores. So that hospital, the facility has 60 years old, or is 60 years old. Yeah, and also we have very a lot of number of schools that have 30 years, 25 years old and older, and older, built with all and past codes, construction codes, design codes, seismic design codes, um, and besides because corruptions for sad in my country, uh, well, one had some consequence like poor constructions. What I'm gonna present today uh, is a methodology, a procedure, how to retrofit all infrastructures like schools or hospitals. Especially what I'm gonna present today is an example for this hospital. Well, um, many of these buildings are made by artisan clay bricks. Some of them following some engineering designs, and we have original draw, like for this hospital that which it is keep working. These artisan bricks form together with concrete columns and beams confined masonry walls. Well, what I'm showing to you is a scheme for for these 3-story buildings, which has 60 meters length for the longitudinal direction and almost 30 meters, almost 30 meters in the transversal direction. Um, well, um, then what you can see, what you can see is that we have a lot of irregularities. Some of these irregularities is that walls are not aligned, So one is one just below the other, making a height irregularity, which is a very poor detail for construction and especially for seismic forces. Another another thing of that is that the quality of the materials is less than 3 KSI or 20 megapascals. As I said, it's also a 60 years old construction which suffered two main earthquakes in Lima, Peru. We propose to use CFRP or carbon fiber laminates in order to strengthen this building. So carbon fiber is for people who is not familiar with that, is a laminate or sheet that provide a high tensile capacity for element attached to this laminate. The thing and the problem here is that laminate can be debonded from the surface. Even though you use a very strong epoxy to keep together the laminate to the surface, both of them in some point of his work life, so gonna debond. That's why it's very important to assure that laminate works together with the wall. Work together with the wall. Work together to the wall, and that laminate arrive or reach the full tension capacity. Well, so I'm gonna present, as I said, effective rehabilitation of severely damaged reinforced masonry wall that can be also, as I said, not old with minor damage as well. Masonry wall, as I said, masonry wall made by by confined concrete beam and concrete columns and an infill panel made by these bricks. As well, the procedure that I'm presenting works also very good for concrete wall only, for reinforced concrete wall only. That's why that methodology is a new procedure. It's a new procedure because it's very easy to apply to several walls of different type of materials. Well, the use of CFRP material so is to improve shear capacity of the wall. We know that the wall works as a shear forces, and let me talk like a structural engineer. So walls work for shear capacity, and also it's very important to reduce the sliding, the sliding of the walls at the top or the bottom. Um, and that's in order to keep, and this is the key, and that is the key that I want to, which I want to show to you. Well, one of the keys. The key is that in order to provide that the laminate works at a full tension capacity, it's very important to use CFRP anchors. Well, so as I said, so this is a work that I started at the University of Texas at Austin, where I did my PhD. My advisor was Dr. James Jirsa. Many of you might know him. Well, I tested several elements, concrete columns, beams, and also masonry walls. First of all, so a wall was a masonry wall with hollowed brick units with the type of materials and lengths, dimensions you can see, was tested using a double curvature deformation test setup. It means fixed for rotation at top and also the bottom. Very quickly, so for this test, so we found sliding at the bottom and also diagonal cracks, which is the pattern, the typical pattern for masonry walls, which we receive very very large lateral loads, high lateral loads. So, well, the point here was to apply diagonal ties together with CFRP anchors. That CFRP anchors at every corner or every stream of every laminate is gonna keep working this laminate, this sheet, as a tension tie. That tension tie is gonna take the most of the lateral load which this masonry wall or concrete wall, or in this case masonry wall, is gonna receive. That anchor which is attached by a fan on the surface of the masonry of the laminate and by a root, that root into this hole, that units are in inches, is gonna keep the CFRP laminate, as I said, working as a tension tie, even though the laminate are debonded from the surface. Well, this some typical anchor is 60 degrees for this fan, or the angle of the fan. So for the the large of this root is 8 inches, and the large of the fan is 6 inches. The large of the fan is 6 inches. So the fancy thing of this is that it's very quickly to install. See, that is me. That is me retrofitting that wall. So for that sliding, we added a concrete ring covered 2 of the 8 lines 8 lines of bricks or unit bricks or courses. First of all is, well, drill the holes, to apply the CFRP laminates. Then to clean the surface, it's very important to work in the quality control of application of this material. And then the application of the installation of the CFRP laminates and ties. So we embedded the CFRP material with epoxy that the providers of the CFRP recommend to us to apply. Then we install the CFRP anchors. That work, it can be made in an hour and a half. Actually, I did that. Just for one wall. And then you can see the wall, so with the different with the different ties. So as you can see that both faces of the wall were applied and attached with the CFRP laminates. And you see that there are two different whites. What happened is that we tried two different amount of transverse area of the laminate in order to see how the masonry retrofitted masonry wall works for different amount of CFRP ties. As you can see, this is the structural response for the lateral loads, and you can see the shear force, shear base force, and also the drift ratio. Well, we got an important increasing of the shear capacity and also an important increasing of the ductility. If we compare, so the blue line or the blue dash line with the original wall and the red lines with the retrofitted walls. We got the bonding. As I said, we got the bonding. What if we didn't? What if we wouldn't have CFRP anchor? That tie won't work. Very simple. That tie just won't work. But because we installed the CFRP anchor, that diagonal tie worked perfectly. This is the thing. How was the pattern of damage of this wall, of the retrofitted wall? The sliding at the top. But what happened? The anchor keep it together, the wall, the infill panel of the wall together to that concrete top. Something that we didn't expect. We expected that the CFRP laminate rupture. However, we saw experimentally that the CFRP anchor was able to keep together that concrete top and also bottom with the masonry wall through the anchor against this sliding. This is something that, well, so we saw in this experiment. We can see also in the other corner how the CFRP anchor was before the test and after the test. We can see, well, you can see what the amount of the sliding. And the CFRP anchor was the one who provided this resistance against the sliding. This is some formulas that we applied, so in order to figure out how the force of the CFRP anchors. Now the modeling. So in order to see how effective is this type of work, so what we did was to make a performance seismic design of a building without retrofit and after retrofitted with the CFRP materials. This is the model. This is the model of the analytical model of the original masonry wall. that is well, so in order to prepare, in order to make a consistent model, so we calibrated our proposal for this model with some experimental work we did for, first of all, a masonry wall, and we create so a shear hinge on one just vertical element, which replace the infill panel and the concrete element and the concrete columns. These rigid beams replace that beam in that beam. Well, so later on, so that dark blue lines are the walls where we apply the CFRP anchors. So we can see that these blue lines, retrofit bearing walls, some like blue lines, like here, which are bearing walls but not retrofitted, because they didn't need. And also we saw some pink lines which are non-structural walls and obviously not retrofitted. So this is a detail. This is the details of what we got. So we use only 9 centimeter wide of diagonal ties, or mostly almost well, less than 4 inches. And what we did was, well, in order to calculate the capacity of the retrofitted wall, was to add the capacity of the masonry wall itself, plus the capacity or what the diagonal provide to the masonry wall. Obviously, so it up the angle of the diagonal. And also, so we calculate the capacity of the pulling force of the anchor. Well, for the computational modeling, so as I say, so we model the masonry wall, so with straight lines, with shear hinges, and as we see, is are the results. For the longitudinal direction, so we found we found a performance point just before or just above immediate occupancy performance, which is very important, which is a very great performance for hospital. Even though for the transversal direction, this is also okay. For this is transversal direction, I'm sorry. It's also okay. For alternative strengthening, in order to validate this work, so we prepare we retrofitted also as an alternative with concrete walls, and so making the performance based design, we saw that the performance points are from immediate occupancy to prevent of collapse. It means that before the failure, obviously. It means that this retrofit work, however, some damage is expected to be appeared that can be retrofitted. However, for hospital, many non-structural elements or many devices for hospital devices may stop working and it can be difficult. It can be a problem. If we compare capacity curves, so if we compare both performance, we saw the blue line, the performance of the masonry walls, which have very good performance, much better at force and ductility, which is very important for seismic, than the concrete wall. And the red line are the original wall. For conclusion, so is it presented a unique project to retrofit masonry walls. So the CFRP diagonal ties together to the arco provide a very important shear capacity for the hospital. And buildings with CFRP materials works much better at shear forces and ductility. a lateral displacement than well conventional techniques as a Mason revolve, which represent also more time to work than the CFRP. Thank you very much. So I appreciate your time. Uh, thank you, Mr. Surendra Makrinsar, for your kind invitation. I deeply thank you to you. Thank you for the to India, for your organization, for your invitation, and well, I hope all of you are okay, and your families or your family is safe. Well, have a good day. Thank you.
Well, welcome, ladies and gentlemen. This is Sunny Surlakar, Head of Technical Services at SS Buildchem and Director of IITD.
Today we are here to discuss some solutions for sustainable construction. And what we'll be talking about in brief would be green concrete, modern formwork, and thermal coating, and how all these systems come together to make construction better, more durable, more energy efficient, and sustainable. Further on this presentation with me was inputs by Engineer Paresh Unarkar, one of the very well-known concrete technologists as well as structural engineers in Mumbai, as well as we were mentored by Mr. Samir Surlakar, who's director of Assist Buildcare. So with that, let's get started with our agenda for today. We'll talk a little bit about introducing the concept to you along with the construction system, like how the whole concept came about and how it works. We'll talk a little bit about green concrete in itself. We'll talk a bit about thermal barrier coating, on how the coating functions, what's its application, how it's used, and so on. And finally, we'll talk about what are the practical applications, what did we see, and what we can do with it. So, firstly, talking about sustainability as a whole, the aim of sustainable construction is to reduce both the environmental as well as the financial impact over life cycle of the structure. That means right from the time the materials are selected, the construction is going on, construction is completed, it's occupied, it's in use, in service, for repair and maintenance, and finally at demolition. So it should add value, or it should rather reduce the impact over this entire life cycle. And that's when we can say that construction is sustainable. So our modern sustainable construction model is based on three basic tenets. So the first one looks at formwork. So using the most modern, most well-known aluminum formworks that are available, designing concrete that is absolutely green with reduced footprint, and using thermal barrier coatings which behave both as insulation and waterproof. So a little bit about the aluminum formwork system. I mean, this has been very popular in cities, especially cities like Mumbai. So the advantages include very rapid erection progress, and the main thing it does is it eliminates block work plaster. So your construction is much faster and the durability is much better. The water tightness is there, the loads are lesser. So overall it adds a lot of benefits to it. So although the formwork system in itself may be a bit more expensive, but over the construction cycle and its reusability, it actually reduces a lot of the financial impact. Now, green concrete is something concrete that is much more sustainable, I would say. So, what we're looking to do is reduce the carbon dioxide footprint of the material by replacing a lot of the OPC with GGBFS. That, of course, leads to much better durability, much more water tightness, and of course, savings in the cost of the cement itself. And overall, because of its kind of durability and the reduced CO2 footprint, the material becomes both very, very cost effective to make as well as very, very sustainable in the long run. The last one is what we call as a thermal barrier coating. So this is material that looks like paint, it's applied like paint, feels like paint, but actually behaves like insulation. So that means it accounts for very large reductions in temperature, or like in case of cold countries, it helps to warm up the structure. And it's based on advanced modern binders and nanoceramic technologies. So overall, in a place like India, what we're looking to do is have 20 to 30% reduction in temperatures, which further, of course, leads to savings in electricity bills and so on. So the core idea is, of course, to increase the durability of the structure by lowering its permeability, lowering the RCPT values. We're looking to reduce the CO2 footprint because we are doing this by optimizing the OPC content and using local materials for making the concrete. Of course, with this whole exercise, we found that we are saving a lot of cost because of the cost of the materials involved, and the kind of construction system, because of the fast aluminum formwork system. It is much faster to construct and much cheaper in the long run because of the reuse of it. Last but not least, of course, we make it sustainable by saving energy and lowering the cooling costs. So, talking a little bit about the green concrete technology, the concept came about, like, it started off with making this concrete at a batching plant on site. What was targeted was to make concrete which is M30 or M35 in grade. Uh, the substitution of OPC was targeted to be 50% or more, a reasonable workability time of about 90 minutes. Of course, admixtures were used both to reduce water, improve durability, improve the flow, and so on. And this led to a new idea, like, could we batch the SCC at site? And the reference of this, of course, came through Unarkar's green concrete technology. That's the name of the firm at Virar. So from there, the first step that was taken was to see, okay, how does the concrete perform on its own? So basically, a fixed a water content or a water cement ratio was fixed. So we used basically 390 kgs of the binder, 233 kgs of water. So water cement ratio somewhere a little bit more than zero point 0.5. There was no admixtures used to in the initial study. What we worked a lot on was using local sands and local aggregates to create an aggregate skeleton. That means we knew exactly what blends to make so as to do this, and only the quantity of this aggregate skeleton was varied for the concrete mix in general based on volumetric requirements. So we tested OPC, PPC, then OPC and fly ash, OPC GGBFS, and OPC and silica fume in different combinations. And it was tested for things like workability, slump at 30 minutes, at initial 30 minutes, 60 minutes, compressive strength up to 56 days, then the water permeability, water absorption, RCPT, and so on. Not go much into the results themselves, but what we essentially saw was that even with the GGBFS mixes, the workability, of course, of those mixes was much better as compared to OPC only. The compressive strength was very comparable. The water permeability values were very comparable. But what surprised us was that the RCPT values were much lower. So that means the durability aspect of the concrete itself becomes much more interesting. The cost per cubic meter at 3838 to batch on site was almost about 450 rupees cheaper as compared to full OPC mix. And this, of course, this kind of mix, we put it into practice. So it has been used at multiple sites in and across the northern Mumbai region. We've used it for an industrial complex, a high 21-story tower building. We're using it for a school building. By far, you can pretty much see how the finishing and everything looks. It's done beautifully. The quality is controlled. And at site, in terms of quality, we actually did a lot of pouring, and we did a cross verification of it. And the concrete was pretty much showing consistent cube strengths of almost about 42 Newton per mm squares. So it was quite a good thing. Of course, we took the codes, we tested the codes, and it is correlated to the cube strength. So overall, the performance was seen to be pretty consistent, and the durability pretty good. So overall, we saved almost 50% of cement per cubic meter, which is almost about 200 kgs of OPC. The strengths were consistently good, over 40 MPa, so strength was not a big criteria. Over 3,000 metric tons of carbon dioxide was reduced because that was the volume of cement which we did not use. And all in all, including the cost of admixtures, we ended up saving almost about 250 rupees per kg, per cubic meter. So the next part was that could we make SCC out of it? So we put together a mix with the modern admixtures like PC. So we're using the best of all the materials, the Maiwan formwork, with the PCE. So we are using the best of all the materials, and even with the PC, a bit of customization was needed. So water reduction, the cohesion, the slump retention, stickiness, a lot of these different kind of aspects, the strength gain part of it, and as well, and the flow, of course. So all these had to be taken care of, and that is what we kind of did with the admixture. So of course we created the aggregate skeleton according to the maximum using a maximum density curve. So we went a little bit on the finer side so that the flow and all the flow properties can be maintained. And yes, we were successful. So a lot of trials, I think we casted over or made over about 15 to 16 different mixes, and finally we could actually achieve SCC. So we did make the mix that met the requirements of flow, that met the T500 time, the V funnel time. It passed through beautifully through the J ring, and what we saw that in terms of compressive strength and everything, the mix behaved absolutely beautifully. So you're getting almost close to 56 to 60 newtons on an average in compressive strength. And even though it was SCC, even though it used a stabilizer, it used a PCE, we were still saving a lot of money as opposed to an OPC mix, like almost about 230 rupees a cubic meter. So that's how we can put to use good green concrete. And from there, we go to a thermal barrier coating. So basically what a coating like this does is that you simply coat it onto your structure, and it helps you maintain comfortable living environments. It reduces your energy cost for heating or for cooling. And last but not least, it creates a waterproof barrier. So because of this, what we're looking to do is save energy over time, save money, and of course save time in the application as well, because insulation is quite a difficult thing to do. So if you can do it simply like a coating, you're saving a lot of time. So in simple terms, if you're looking at a structure without thermal barrier coating, the temperatures normally seen are say about 31 to 46 degrees depending on summer winter variations. and most of the heat is absorbed by the building. But in the case that you're using a thermal barrier coating, most of the heat is reflected and emitted by the coating itself, and it allows very little heat to permeate through the building, in which case your temperatures in practice were seen down to 21 to 26 degrees depending on seasonal variation. So how this material works is basically on the concept of like it basically reflects the heat, like most of the heat is reflected directly from the surface of the coating, and also it has got a very high thermal emittance, which means whatever is the balance of the heat is kind of absorbed away from your coating. So basically, very little of the heat, like hardly about 2 to 2.5% of the heat actually enters your structure, and it remains much cooler in the long run. This kind of a coating, of course, it works better if you do it both inside and out. You can do it over your plaster, you can do it over your gypsum, brickwork, blockwork, whatever it is. So what it does is it protects your structure against thermal gain, and it also protects it against water and weather. And the secret to this is the ceramics. So the binders, of course, is a very interesting matter, subject topic in itself. But the key ingredient in that is the ceramic part of it. So just to see it like in terms of a test, what we did was a simple, we call it as a griddle test. So we just take a griddle, we heat it up. So you can see that from the coating side, it is about 75 degrees, and on the uncoated side, it's going up almost up to 175 degrees. So that's quite a lot of heat to be reduced. This is, of course, not in a building condition. A building will never get heated to those kind of temperatures, but it pretty much gives you an idea of the efficiency of these kind of coatings. And even at high temperatures, it really reduces close to about 100 degrees of the 100 degrees of the temperature. And this is simply because of ceramics, because it addresses all different modes of heat transfer and is very efficient at reflecting the heat back to the source. Of course, this kind of a thing, since it works as insulation, it also works very well after the coating gets dirty. So all in all, it's a pretty interesting product to see, because one is it looks and feels like paint. So it's low in VOC. Of course, it provides an insulation. It's waterproof by default. The weathering properties or the UV properties are very good. It's resistant to chloride and carbonation. Green, saves money, and overall improves the efficiency of your systems. And this kind of material is available in India at the moment. We have tested it. We have tested it in depth at IIT for physical properties and at CEP for the insulation properties. And you can see very well that the application of this kind of a material is very easy. So it looks, feels pretty much like paint. So you apply it with the standard spray gun. Voila, it's easy to apply. You prepare your surface, apply the coating. It's as simple as that. No complicated methods, no PUF, no finishing, messy materials, nothing. So it's a very easy to do things, and so it really helps. So the next idea we saw was how we could bring all these three concepts together on a PMAY, that is a Awas Yojana project, which is like a low cost housing. So the total built up area was about 47 lakh or 4.7 million square feet. But the total area of one building was roughly about 28,000 square feet. So we did a total cost comparison, like what would a conventional building entail, and say using this SCC formwork, the SCC formwork and the thermal coating system, what it would entail. And we kind of made a cost comparison between the two. So what would be the basic cost of construction? So even considering all the different heads, we actually found out that the building made with the modern formwork, made with self-compacting concrete, made with high-grade PCs, high-grade thermal barrier coatings and everything, the total cost per square feet worked out almost 22 rupees per square feet cheaper than the conventional method of construction. So what this meant, or in terms of this one, in terms of savings, was that we saved almost close to 6.3 lakh rupees per building, and which meant that over the cost of the entire project, over 10.75 crore rupees could be saved. That's quite a lot. It's almost close to 100 million rupees. So all this with the benefits of high durability, lower maintenance, reduced carbon footprint. It is much faster to construct. Savings in electricity and lower capital cost. That means lower cost of initial cost of construction. So all these kind of things makes it very interesting, because this kind of a concept is applicable to mass housing, which India desperately needs at this point in time. We are doing it in a very eco-friendly way. We are addressing both environmental as well as the durability concerns in the concrete. We can meet most, I would say, strength requirements. So like even designing 50 Newton, 60 Newton, 70 Newtons is not going to be a problem. With the right aggregates, with the local aggregates, so we are not very choosy about where the materials comes from. The thermal barrier coating, of course, it functions both as insulation and waterproofing, so it saves both steps, provides a lot more benefits for a easy kind of material, and of course saves energy over life of the structures. So it's quite an interesting concept as a whole, which we feel can really help the Indian construction industry in the time to come, and hence we thought it prudent to share with you this concept. So once again, thank you very much for giving us the time for listening to a new concept. And of course, if you have any more questions about this, please feel free to write to us. We have my details on the screen, and you can just take a quick screenshot of this, so you can give us a call, and we'll definitely get back to you with the questions. Thank you very much. Have a nice day.
Hello, my name is Sadık Alper Yıldızel. Currently work in Karamanlı Mehmet Bey University Civil Engineering Department. Today, I am going to present construction planning under different circumstances. Why do construction projects always tend to delay? There are many reasons, but in order to summarize these causes, we can say bad management, stakeholder conflict, lack of communication, lack of project planning, lack of proper monitoring, lack of understand, clients' relentless changes. There are many related studies in the literature. We can see from here. And another question, is every construction project unique? Project is a unique transient endeavor undertaken to achieve planned objectives, which could be defined in terms of outputs, outcomes, or benefits. A project is usually deemed to be a success if it is achieves the objectives according to their acceptance criteria within an agreed time scale and budget. According to the APM's definition, Sir John Egan report claims otherwise. Construction industry should stop making that argument and start learning from production industry where projects are replicable. What is construction worker productivity? Why is it important? Why it is important? Productivity is defined as the rate of output per unit of input. Alternatively, it is maximization of output while optimizing the input. In construction industry, it can be seen the rate of labor cost to produce quantity of work. And manpower is one of the most important resources in construction. And another question, what are the things that construction worker productivity is dependent upon? Weather condition, working environment, safety, job safety, management approach, and salary. And the definition of the planning is here. And I'm going to summarize the planning techniques. Bar chart, this type of planning and control is the oldest and simplest one among the other planning techniques. And also this system is foundation of some others. And again, it can be used for small and simple projects which do not have huge number of activities. It is visual and easy to understand and follow. However, it does not show the links between activities. Further, it is not capable of showing either the resources or what-if planning. If the project is quite small and has very few activities, it is useful. Otherwise, it is not adequate for the big size of the project. And linked bar chart based on critical path network. It is more complex than the bar chart and enables to use the project in which activities has different resources. Although that it limits the number of resources, hence it is not sufficient to use for either big projects or projects in which require large number of resources. On the other hand, it gives an opportunity to calculate fixed duration like all deterministic networks. Similarly, it can create what-if plan and show the possible results. It is useful to represent program as visualized. It can be said that this is the appropriate to use as an analytical and planning tool. In this system, a buffer is built into each activity. Hence, when it calculated as a whole program, it tends to take longer time. Project evaluation and review technique at Monte Carlo simulation. This method is also known as PERT. It is based on defining the critical path and works by giving a range of durations for the activities on the critical path. It includes earliest start, earliest finished, latest start, and the latest finished. On the other hand, because of the computer-produced simulations by considering random durations, it reduces the reliability of the results. The other disadvantage is when different resources are used for the different tasks on the different start dates, it might be a struggle to determine the start date. However, If the activities are executed on a different time by the same resources, it might be recommended. Under these circumstances, especially in today's world, under pandemic circumstances, this method is adequate for larger projects. Probabilistic critical path analysis. This method gives an opportunity to set a range of probabilities for the durations. Unlike the others, on this method, it is possible to build buffer for the whole program instead of each activities. This enables to get more realistic results. If there's an uncertainty about scope of the project, this is appropriate to be used. On the other hand, if the project involves with the loss of companies, this becomes a limitation for this method. And another widely preferred planning technique, critical path method. This method is based on the definite time. Each time or work duration is defined by only one work rate. An active plan-based critical chain method. According to the traditional approach, critical chain consists of 5 steps of following: creating baseline plan, defining critical chain, defining non-critical chain, completing buffers, and inserting buffers. So, which technique to be used when unknown becomes the usual? The most widely used software, Primavera, MS Project, Tylos, SAT Power Project, works based on critical path method. However, when uncertainty increased, CPAM requires an extra time to either each activity or a dummy activity to work schedule. In case of this leads uncertainty and complexity in the work schedule. Which technique to be used when unknown becomes the usual, as we just mentioned before. Here you can see work activities and their units and their region. Planning techniques, durations calculated as per PERT or PERT technique. You know, we have 3 times value, the most optimistic, the mean value, and the pessimistic value. We can calculate the work duration, average multiplied by 4 plus optimistic duration after plus pessimistic duration over 6, and we implement this duration while scheduling our program. Is PERT proper technique to do planning during pandemic? Things to be determined before doing planning. What is disease spread rate? Any foreseeable lockdown? Increase the uncertainty while we are planning a schedule or preparing a program during pandemic. The uncertainty is also increased. Decrease durations for each scenario. Increase the weights as per the split rate. Normal duration, optimistic duration, and pessimistic duration we just discussed. And as you see, different duration or foreseen times for each activity. Especially PERT is firstly used for the Moon project by NASA, as you know. It depends on the probability, not a certain time or duration for each work tasks. Can we use without any certain duration for each working activity? And is it possible to, or is it possible to replace with the PERT program with CPAM, traditional CPAM method? According to our study, we can use PERT under uncertain circumstances like pandemic. Thank you for listening. I wish all of you
Hello, welcome to my presentation on engineered cementitious composites for masonry and concrete structures, necessity to post-COVID construction scenario for Indian Construction Week 2020, which is going to be held during December 1st to 5, 2020. I am Professor Shamsher Bahadur Singh, working at Civil Department of Birla Institute of Technology and Science, Pilani. So this is brief biodata. Now, why do we need, what is necessity of this material that we call engineered cementitious composite materials? And you know that now materials which mimic natural materials but more efficiently and effectively tackle damage, that is biomimetic man materials with built-in self-healing capability to repair structural damage, is going to be very efficient for post-COVID situation in the construction sector. Secondly, reduce cost of repair and maintenance, that is reducing disruptions and increasing reliability, extending lifespan of structure, environmental friendly constructions and infrastructures is another features of these novel materials. Thirdly, here increasing sustainability by using the less raw materials, wherein self-healing materials will ideally repair the damaged area and regain strength and durability. By reducing the brittle nature of concrete, engineered cementitious composites have opened a new world of possibility to enhance the safety, durability and the sustainability of civil engineering infrastructure. With strategically designed microstructures, ACC features with the incredible ductility and tensions, which is seen earlier in ductile metals only. ACC also have the intrinsic capability for self-healing, unlike any current cementitious alternatives, reducing the percentage of cement which is used in ECC or substituting with appropriate alternatives, namely exploring green low strength ECC could turn the tide on greenhouse emissions, which is caused by production of cement for the same volume of ECC which is produced. Most importantly, we can have the pre-cost construction, which is easier for fast construction and strengthening of all deficient structure system, and that will definitely reduce the number of people gathering together, right? And also going to be construction very faster. This kind of ECC could help in the efficient structure systems with reduced manpower requirement and less time of construction. Now we show that now we can say that how ECC differ from FRC, that is fiber reinforced concrete, which is being used mostly in India. ECC has taken now some of the institutions are working on development of cementitious composites, which is one of them is ECC, which is also called bendable concrete or also called high performance ductile concrete. So you can say here FRC normally after first crack strength it reaches, it is going to have softening behavior. It means that FRC has lost its strength and stiffness after first cracking. But in case of ECC, after first cracking, you can see here we have the strain hardening behavior that is basically generated from concept of multiple cracking that is being designed. That we call engineered cementitious. We are calling because we are designing this material to behave and give the required engineering performance. Thus we call it engineering materials. We can design high performance concrete, high performance ductile concrete. So this is for high performance ductile concrete. Basically we are saying that this strain hardening feature is one of the most important feature of ECC, which is not present in case of fiber reinforced concrete. And definitely the construction sectors now must utilize as much possible for ECC. Now you say that is the ductile behavior of ECC bendable concrete. Now some of the properties, usually we need this kind of materials, polymeric fibers, then cement, then some of fly ash, some admixtures. So one of the features that we hear in our research work, we have got polyvinyl alcohol fiber from Kurare company, polyester fiber from Reliance India company, so that you compare the response. Thirdly, people have also used the polyethylene fibers. Now in the future is we can utilize the natural fiber also as a sustainable material for making or developing ECC materials. There are some of the features that is given here: the cement, microsilica sand, fly ash, water, pasteurizer, polymeric fiber. A polymeric fiber could have of different kinds that could utilize, and again this could be substituted by natural fiber or some other pictorial view of this kind of content here. Now, firstly, in case of when comparing the ECC properties, we just check the performance of PVA-based ECC and then polyester-based ECC. Polyester-based ECC was based on Decron fibers, which is given by Reliance India, and PVA fiber was given by Kurare company from Japan. And we see definitely here one typical tensile stress strain characteristic. If you're looking at that, polyester-based ECC definitely have the better characteristic that polyester-based ECC. Although we can say that polyester-based ECC have a low strain, but both are showing the ductile performance. So definitely we have the indigenous fibers are available in addition to the natural fiber that will feature research for developing the engineered cement composite materials. There are some applications. ECC could be utilized for deck step construction, even beams, and we are going to show some masonry beams. It could be utilized for retrofitting structure in form of precast constructions, or even for new structures, or for reducing the amount of reinforcement in the structure. The ECC could be used for different form for old structures as well as for new structures. Application obviously for strengthening of masonry structure. Here say that masonry structures have low tensile strength, brittle nature, and is affected that by repairing the masonry structure with ECC, ductile ECC, we can get high flexure strength, ultra high ductility of structures. The flexure response of masonry beams without strengthening. Some are typical. We have made a kind of masonry structure with the interior portion clay brick, which are of low cost materials, and then we are using here ECC or cement based bed joint, and we are examining the effect of what is the effect of replacing the cement mortar as a bed joint by ECC as a bed joint. And we see that here this some of the manufacturer developed beams, especially masonry beams with the coated. Now we in fact we have investigated, examined the effect of ECC as bed joint, cement mortar as bed joint for this cross section of masonry beams, which is developed with the ECC as exterior layer here. But replacing, we can two kinds of bed joints, we utilize ECC or cement mortar. Different 6 kinds of strengthening mechanism that have been developed here. This is only just control beam with this cement mortar as bed joint. Second here ECC as a bed joint. Third, you are strengthening this beam structure with the CFRP or GFRP fabric sheets, or the teeth or U wrapping, shear strengthening, or continuous wrap shear strengthening mechanism. And additionally, then 2 important features of flexure strength that we have CFRP bar, we are embedding in the ECC at the bottom layer tension zone have been provided, or we can apply here near surface mounted bar FRP bars for strengthening mechanism. And then we check the behavior of response of this structural system. There are some of the typical failure modes. We say that when we are doing flexure strengthening, bifabric is failing shear because of high strength, shear strength reaching first earlier than flexure strength. Then if you are changing the U wrap from the continuous wrap system, the shear mode of failure is changing to flexure mode of failure. Then in case of pull-to-thread bar, we are embedding in the ECC at the bottom layer, the tension zone, we are getting flexural failure. Again, in near surface mounted bar, begins flexure strength reaching first, shear strength reaching first earlier than the flexure strength. So shear failure become critical in this kind of scenario here. Now, just like here, we just comparing for all the six kinds of strengthening mechanism, we are finding here that even for control beam, say that replacing the cement mortar as a bed joint by ECC as a bed joint, we are getting here very significant improvement in load carrying capacity, almost about 6 times. Or again with the strengthening mechanism also say that line so that ECC as bed joint, solid line represent the cement mortar as bed joint. We are finding that ECC as bed joint, when you use all the strengthening mechanism, we are getting the improved performance or better performance obtained for all kind of strengthening mechanism with ECC as a bed joint rather than cement mortar as bed joint. So this is all for, again, most notable features of this examination study was also that when you are embedding the FRP bar as a pull-to-thread bar in case of in the ECC layers, we are finding that significant ductility is observed with enhanced load carrying capacity. Definitely this kind of structure mechanism, strengthening mechanism can give idea of how the performance of structures could be improved. Even cast ECC layer here, now secondly, we are putting near surface mounted bar, we can see that ductility is often, although load carrying capacity very high, improving with this is there. Trends are similar, but ductility, as in case of pull-to-the bar embedding, is not seen in this particular structure. So this study is very, very important from the point of understanding how the structure response could be improved by using the ECC at bed joint. Then here we see that pre-cost. In further study was done, we wanted to examine the response of ECC as a pre-cost strips. Just like the FRP strip or steel strips are developed, we develop ECC strip and try to configure the structure in the form of sandwich construction or tension zone strengthening and examine the response. So we can see here that this is our testing feature. This is just like say masonry with this ECC layer at top and bottom, and we just examine how the sandwich construction could be helpful for improving the structure response. Before that, we tested each and control masonry beam was of 1/2 millimeter check, then ECC control strip of 35 millimeter check for flexure strength and mid span acceptor is checked here. Then we have epoxy bonded tension strengthened beam, a cement mortar bonded tension beam, then sandwich construction method. In this case, a precast construction bonding agent was also important. Whether we examined here epoxy bonded sandwich beam or cement mortar sandwich beam, or epoxy bonded tension strengthened beam or cement mortar bonded tension strengthened beam. So then we have the examine the experimental response. Then experimental response was validated by here a Baker's result we are going to show here later. Before that, here we have validation of results. We see that this response with the sandwich construction here showing very high load carrying capacity and also ductility is seen here in this case here. There are some of the typical failure modes of masonry beams, which is say that epoxy bonded sandwich beam. This showing cement mortar bonded sandwich. This is control beam, and this is epoxy bonded here tension strengthened beam. So we are putting the strips only on tension side for masonry structure. Numerical modeling is done by a Baker's, and then we can say three-dimensional 8-node elements, linear 3-dimensional brick elements are used for masonry ECC. Then cohesive elements were used for epoxy. Then concrete damage plastic model have been used for masonry and ECC. Then this is PC configuration that utilized, and this numerical study by Baker's has been compared with the experimental results. And for most of the cases here with sandwich beam or tension strengthened beam, we find that our numerical study are capturing the maximum deflection, maximum load carrying capacity, which is most important parameter of design. And most cases also you see that it is also capturing or very consistent with initial stiffness, but certain cases definitely here initial stiffness are not matching all the cases, but ultimate load and deflections are being captured and validated by this numerical modeling. And that modeling, after getting some confidence, we strive for parametric study to recommend what kind of thickness etc. required for this case here. So now experimental study here, numerical study validation have been done in tabular form, have been presented. Some of the errors, percentage peak in the results have been obtained, percentage which are very close and consistent results for civil engineering point of view we are getting here. Now from the results of parametric study, from most important features that you can say that we try to see that by putting the compressive layers of ECC constant thickness, but changing the tensile zone thickness of ECC strip, we are finding that in load carrying capacity of sandwich beam increasing with increasing thickness, right? Unlike in case of that is for epoxy bonded sandwich beam, but in case of cement mortar sandwich beam here, this kind of response on RC load, the load carrying capacity increasing, but deflection is not increasing. The ductility not seen here. Right? Again, another feature that in increasing thickness of ECC strip on compression zone, whether cement mortar bonded or epoxy bonded structures is not seen, that is not showing to be more important. It's not showing significant improvement in the load carrying capacity with increasing the thickness of ECC strips in compression zone. Similarly, if you also find another feature that found that lower the thickness of your mortar, say if an epoxy bonded sandwich beam is for 0.5 to 0.8 millimeter thickness of mortars, we are getting the good response, better response. Even this happens even for cement mortar also, lower the thickness of mortar joints, better the response that we are obtaining because of chances of deficiency and the cracking that it pertains cement mortar is reducing strength here. The application of the PVA-ECC in reinforced concrete beam as strengthening material here in the concrete beam. So first we talk about masonry beams. There are some of the experimental studies I conduct. Number of beams were costed with the plastic hinges. We develop plastic hinges as well as EC strip for external strengthening and try to see what is the response of structure coming with the introductions of plastic hinges made of ECC or introductions of ECC layer as external strengthening materials. These are some. Then two kinds of beams were designed: under reinforced beam and over reinforced beam, and then testing. This is out you can say loading pattern for testing. These are the plastic hinges. A different length of plastic hinges have been used: 200, 400, 600 millimeter, and then we have ECC layer of flexible strengthening have been done, and examined response have been examined. From that, we have also normalized load parameter because we have checked different kinds of load span have been, length of plastic hinges are different, materials are different, spreader beam is different. So we try to normalize the response so that it could be valid for any load span or any materials and geometry for the beam. So we find out here that case of a over reinforced beam. In the case of over reinforced beam, if you are using a 600 millimeter plastic hinge length, load carrying capacity increase significantly. Also, unlike normal or over reinforced structure, we are getting brittle response, we are getting response, ductile response. So this is most of the important features of this kind of plastic hinge if you are going to introduce in the concrete structures here. Even for over reinforced beam, we are getting ductile failure mode. And these are some typical. If the ultimate failure of over reinforced beams is governed by definitely flexure crack at tension side. Other cases we are getting the compression failure. Similarly, case of under reinforced beam also, although in the under reinforced beam normally expecting the flexure failures are ductile nature, but again plastic hinges there also improving the load carrying capacity significantly for 600 millimeter length. Definitely geometry at length of the plastic hinge in comparison to the overall length of beam had to be designed properly to get the significant load carrying capacity. So without loss of your ductility, we are getting significant improvement in the load carrying capacity of even under reinforced beam. There are also failure modes. You are getting under reinforced, we are getting multiple cracking as expected, but in case of 600 millimeter plastic hinge length, here single crack has finally lead to the failure of structure beams. Similarly, here even for external strengthening of ECC layer also, we are getting 70 millimeter thick ECC strip at bottom side or tension zone has improved the load carrying capacity, right? And significant ductility also observed here. Here also this is ultimate failure of the all under reinforced beam occurred due to flexure tension accompanied by yielding of internal reinforcement here. In case unlike under reinforced ECC strengthened plastic hinge beams, the under reinforced ECC beams have not shown micro cracks. So we are putting the external strengthening ECC even under reinforced beams have not shown multiple micro cracks. That's the only difference here that is coming the flexure behavior. Now in case of over reinforced beam also, we are getting the with the external strengthening, we are getting the higher load carrying capacity, but horizontal plating is not often here, but we are getting ductility is still present here. If you just like say 80% over the peak load we are taking, then we can get significant strength without loss of ductility, without loss of reduction strength that is available even for. This paper have in fact, this is part of my paper that is published 2013 for Indian Concrete Journal. The ultimate failure of all over reinforced beams occurred due to crushing of concrete at compression side, that is observed. Now, in final part of my study here is we are going to show effect of significance of ECC in the framed structure, one designed by IS 13920 2002, one was designed as a normal RCC design for IS 456 2000 used for reinforcement, and then in each case the reinforcement design here three kinds of frames for structure. One is completely made of ECC, second here made of pure metal of concrete, thirdly we are using ECC at a discrete location, a critical location, and examining the performance of structure system. So this is that now if you are these are reinforcement for IS 139020 2002, and second as per IS 456 2000. There is reinforcement configuration, and this is loading setup pattern we are talking about. Now, if we are taking design the load versus deflection response of beam frames that is made by IS 1392 2000 code, then we are seeing that here the structure is completely made with here. This is completely made with the ECC. Definitely, I expected a higher load carrying capacity performance than this is concrete. Orange one is concrete only, and then this is the In between that, we are getting the response of frame structure when you are using concrete at and ECC at a discrete location only. We are getting load carrying capacity slightly lower, but ductility is still available. This is not the problem here. Now, second case, when reinforcement are very less, because as per IS 456, we are getting similar kind of configuration we are used. If we are getting complete ECCY present here, response here, this is the only ECCY, only that few location at the point of critical location, we can say that ductility is very much present here in both the cases. Load carrying capacity is slightly low, but still we are getting ductile response. So we can say that even the frame structure design as per IS 456, and we are putting the ECC only at discrete critical locations, we can get the desirable response of structure, we can get ductile response of structure, and that helps in reducing the amount of reinforcement that is required as per IS 3092. So this is some typical figure that you can say that if you look at the ductility for both the cases, category 1 frame, category 2 frame, category 1 were designed as per IS 3090-20, category 2 are designed as per IS 456 as per reinforcement. Reinforcement ductility factors are very much close in the both the cases here. DFR concrete 456 is be very much closer to whereas DFR is very close to the ductility factor that is obtained completely made of ECC layer 3.7 weight. So this is definitely we can say that IS 456 design with ECC at discrete location will be very much helpful. Finally, we can say that, and briefly, I like to give the conclusions and recommendation. We can say that in case of masonry structure, if you are using the ECC at a bed joint, performance will be almost 6 times what we can get with the cement mortar as a bed joint. Secondly, thirdly, here, if you are using the ECC and you are using the pull-throated bar, using the embedding the pull-throated bar in the ECC layer in tension zone, masonry structure performance will very much improved, ductility will also improve, load carrying capacity also improve. Some are important. Thirdly, we can say that here, definitely use of continuous CFRP, GFRP wrapping, as you know that for shear strengthening, changing the mode of failure from undesirable shear failure to most desirable flexural failure, and others. Some recommendation that we are going to make here for tension strengthening being the recommended thickness of ECC strips are 45 millimeter when using the epoxy as a bonding agent, and 50 millimeter if you are using cement mortar as a bending agent. In case of sandwich beams for masonry beam, we are finding that recommended thickness of ECC strips, that is external layers that you are putting for sandwich, are 50 millimeter in case of epoxy and 45 millimeter for sandwich, that is sandwich beam with cement mortar as a bonding agent. So that we can see that here these recommendations are used for if you are using ECC strip for external strengthening in the form of that is or you can say new structure for sandwich construction or only for tension strengthened beam. So this is this project acknowledgement. This project is part of DST's project, Department of Science and Technology, and 2000, which was granted in 2012. So thank you very much for your kind attentions. And if you have any questions, any of audience, you can reach me by phone or by my email that is given in my slide. Thank you very much.
Ladies and gentlemen, I'm pleased to be with you. I'm Aslı Özborat Tarhan. I'm the Secretary General of Turkish Ready-Mix Concrete Association, THBB, and the Technical Manager of European Ready-Mix Concrete Organization, ERMCO. I will present the effects of COVID-19 on the Turkish ready-mix concrete industry and the best practices implemented in Turkey. I will first of all present the Turkish ready-mix concrete industry, then summarize the effects of COVID-19, and then report on the best practices implemented in Turkey. Let's start with the Turkish ready-mix concrete industry, and let me introduce you the Turkish Ready-Mix Concrete Association. We have been serving our industry for the last 32 years. We are presenting the sector with 67 members, which represents the 70% of the whole Turkish RMC industry. We work hard and effectively with our 31 employees. We work with 157 industry experts within 4 different committees of THBB. We have provided trainings to more than 16,000 industry employees in the last 32 years. In 2019, we organized 25 trainings and seminars all over Turkey. In the last 2 years, we have provided practical, economic, and safe driving trainings to more than 1,600 operators. We are member and the regional system operator of the Concrete Sustainability Council, which is located in Geneva, Switzerland. This council was funded to implement a certification system showing how the concrete and its supply chain are environmentally friendly and sustainable construction materials. So in Turkey, we have certified 12 companies, including concrete and cement plants in the last 2 years. As THBB, we organized 28 congresses, fairs, and competitions in the last 32 years. We have an enterprise called KGS, a third-party certification body, and by this certification body, we've performed 2,689 audits in Turkey. We have a building materials laboratory of THBB, and we have performed concrete strength tests, mechanical tests, chemical tests, and calibration services for all our members and for all the stakeholders. We have reached more than 13,782 followers on our social media channels such as Facebook, LinkedIn, Twitter, and YouTube channel. These are the numbers as of November 2020. Let's look at the sectoral statistics. Here you can see the RMC production of Turkey. In 2017, we reached a value of 115 million cubic meters. When we started producing RMC in Turkey, it was by the end of 1980s. So at that time, the production amount was around 2 million cubic meters. But now we are producing 67 million cubic meters. If we take into consideration the amount produced in 2019. The annual production per capita in 2017 was 1.43 cubic meters, and in 2019 it was 0.82 cubic meters. We are the biggest producer in Europe. As you can see here, when we take into consideration the total amount produced within European Union, in 2019 it was around 260 million cubic meters, and as Turkey, as you can see in red, we produce 67 million cubic meters. We have 900 batch plants in Turkey. The average concrete strength used in Turkey is C30-37, and SEM1 is the mostly used cement type in Turkey. I will present very briefly a new identifying and tracking system which is actively used. So as Turkey, we have the building inspection system. And in 2019, a new directive came into force to ensure the full control of concrete in compliance with the new earthquake code and to enhance the traceability of concrete quality to the end users. And for this purpose, now all the truck mixers loaded with ready-mix concrete are identified by a unique RFID tag. It is useful to link the truck mixer license plate to the producer and to the product. All the concrete samples taken by the third-party laboratory, authorized, of course, by the ministry, are identified by a unique RFID tag, which is inserted, as you can see on this video, inside the fresh concrete. The RFID tag is identified by a hand terminal, and all the information about the product is sent to a cloud-based system. The concrete samples identified by a unique RFID tag is stored in curing containers once they are demolded. Of course, the curing conditions are crucial, so due to the importance of the curing conditions, the curing temperature is monitored by the ministry system remotely, digitally. All the curing containers are equipped with sensors and transmitters. And when the concrete specimen is tested to measure its compressive strength, the compression testing machine can recognize the specimen by its RFID tag. All the compression testing machines, which are located at the third-party laboratories, are equipped with RFID tag readers. And after the test, the results are saved by the cloud-based system. Of course, by this directive, which came into force in 2019, identity testing obligation was extended and the concrete samples are digitally tracked. Of course, to trace the quality of concrete was the main purpose, but taking into consideration the actual status caused by the pandemic, I think this system is really helpful during this quite difficult period of pandemic also. So let's look at the effects of COVID-19. Here on this graph, you can see the growth compared to the same month of the previous year of the RMC production, starting from beginning of 2019 till September 2020. During the lockdown, the construction industry continued to work contrary to the other European countries. Hence, the demand on the RMC was not influenced dramatically, as you can see on this graph. After the lockdown, then starting from June 2020, an unexpected demand was realized, and the ready-mix concrete production has been continuing at a good level since June 2020. Let me present you the RMC index. It's a study which is carried out by THBB in cooperation with an independent consultancy company. This company, on behalf of THBB, is collecting data from our members, and based on these information, the activity index, the confidence index, and the expectation index are determined, and taking into consideration these three indexes, the ready-mix concrete index is calculated consequently. As you can see here, starting from June 2020, these indexes, and especially the ready-mix concrete index, seems to be above the threshold value of 100. So it's quite similar to what we've seen on this graph. So the issues related to pandemic, cement storage. Due to the shrinkage in local market and the depreciation in Turkish lira, the cement producers focused on export. For this reason, the RMC industry had difficulties in supplying cement. Unexpected demand. During the lockdown, the RMC companies preferred to shrink, both in human resources and equipment. But after the lockdown, unexpected demand was realized, as we've seen in the previous slide. And the production cost. Due to the influence of COVID-19 on economy, the inflation raised and the value of Turkish lira decreased, so the production cost increased. Uncertainty is another important issue. The pandemic caused disruptions in all processes, and employees' testing and quarantine necessities created organizational problems, especially in production and delivery. Let's look at the best practices. So here you can see the guide for ready-mix concrete companies during the COVID-19 pandemic. This is a guide prepared by ARMCO in cooperation with the Latin American Federation for Ready-Mix Concrete, FIB. So this guide was prepared first of all in Spanish, then translated into English, and then all the members of the European Ready-Mix Concrete organization, ARMCO, had the opportunity to translate this guide into their own languages. And similarly, THBB translated this guide into Turkish. Here you can see this guide in Turkish. And this guide is composed of 3 sections. The first one, the first part gives the details on what should do or what shouldn't do the truck mixer and pump operators. What are the precautions that should be taken in the truck mixer, and what should be done during the loading and unloading of concrete. If you would like to have more details on this guide, you can have this guide in English on the website of ARMCO and the Turkish version on the website of THBB. So let's look at the best practices. Trainings. Here you can see an example of the trainings, which is hand washing trainings. So to raise awareness, hand washing training kits were distributed to personnel just to show the microorganisms that mimic germs in the UV light to spot the remaining germs on the hands after washing the hands, to understand how properly or improperly they washed their hands. So it is one of the examples of trainings just to raise awareness. Of course, social distance is quite a crucial parameter. So some measures have been taken to ensure the social distance in the plant. For this purpose, unemployed, unauthorized persons are strictly prohibited from entering the power plant and weight bridge cabin. Operators were informed that they had to disinfect their hands after the delivery note exchange. Masks, gloves, and hand disinfectants were distributed to all personnel. It was informed also that contact with pump controls and truck mixer concrete chutes must be done with disposable gloves. Hand disinfectants were given to all personnel individually. Arrangements to minimize social distance. So necessary arrangements have been implemented, especially in the cafeterias. Some separators are placed on the tables, nameplates are affixed to the tables, and only one person can eat at each table in the cafeterias. Meals are served as a package, in a package. To improve the immune system, the necessary food is provided to the staff. Water is supplied to the staff in plastic bottles. And as you can see on the picture on your right-hand side, delivery ticket boxes are placed outside in order to prevent contact caused by exchange in the plant batch cabinets. Special protective overalls for operators were provided. So the operators have to wear these protective overalls when they start working at the plant and when they are on site. So daily disinfection and disposal of these overall protective overalls. At the end of the day, the protective overalls with the name of the staff are subjected to disinfection. Disinfected protective overalls are worn at work the next day. The protective overalls that have expired are thrown into medical waste bins at the facilities and collected in padded containers, and the waste demand is created from the system to remove the accumulated waste. And for the disposal of medical waste, the licensed company authorized to collect the waste is contacted. Disinfection of vehicles, rooms, and offices. Of course, to disinfect all areas and vehicles at the plant, disinfection device and liquid approved by the Ministry of Health is provided. The application is made in daily periods. So toolbox conversations and trainings are conducted outside, paying attention to social distance rules and special medical services. So a scanning test setup was formed in collaboration with some private hospitals at the plants in order to ensure that the contacts of COVID-19 positive employees take the test. Consultancy was taken from the medical team specialized at epidemic diseases at the private hospitals for 2 days in a week regarding the measures taken at the plant. Ambulance shuttle was organized in a way to respond 24 hours, 7 days, along with 8 health professionals and the emergency support line. A detailed inspection was conducted by the occupational health and safety team and the medical team of these private hospitals regarding the usage of masks and other measures taken at the plants. Some employee assistance programs were launched. These programs are accessible to all the employees and their family members, and these programs were initiated which offer 24 hours, 7 days consultancy and information service on potential stress causes that they would like to seek with help. And the service includes medical, health, nutrition, and psychological consultancy via phone, as well as for online psychological counseling sessions. What else? Online meetings have been held, flexible working hours have been implemented, agreements with health institutions for COVID-19 tests were signed, thermal cameras and digital thermometers have been used. The number of transportation services for the staff has increased to have less people in the cars, in the shuttles. Those in the critical group were allowed to work from home. The references that we've used, Turkish Statistical Institute data, the European Ready-Mix Concrete Organization statistics, Turkish Ready-Mix Concrete Association survey based on the feedback of our members, Çimko Cement and Ready-Mix Concrete Company presentations, Akçansa Cement and Ready-Mix Concrete Company, Heidelberg Cement Turkey presentations. So thank you very much for your interests. Have a nice day.
Hello, everyone. Dr. Surendra Manjrekar. Hello, how are you? First of all, my name is Bernardo Tutican. I'm from Brazil. Good morning to everyone. Here now is 9 a.m. First of all, I want to thanks to it's a great honor to be here to give this speech with this invitation, this kind of invitation of my friend Surendra in this very important event, the post COVID event. So thanks to everyone. My name is Bernardo Tutican. As I said, I will present about how new and durable concretes can improve the structure service life with low maintenance cost. We, with this COVID and even before the COVID, we need to prepare better structures with greater service life with low maintenance cost. It's important to our structures, mainly in our countries like Brazil, India, and developing countries that have few money to maintenance costs. So when we build a bridge, when we build a building, we need that structures they need to have a great service life with low maintenance costs. So these concretes that I will present to you or improve your knowledge about them is concrete with this main goal. So I will present. This is my email, bftutican@unicinos.br. You can send me messages. You can send me some questions. I'll be online on the time that we agree with Dr. Surendra. So it's nice to be here. Thanks a lot. The first concrete I will introduce to you, it's the textile reinforced concrete, the TRC. The textile concrete is a fabric manufacturing process to guarantee the same rate of reinforcement over the entire length of the material. So we will guarantee the reinforcement of concrete in the direction of the main stress. So this is the picture. We will replace the steel reinforcement by this textile reinforcement. So we won't have corrosion process. We will have a structure of greater service life, because the corrosion is our main problem in the entire world, the main pathology in concrete structures. So this attempt is a way to avoid this problem in our structures. So we will put a cement matrix to involve the textile reinforcement. So this cement matrix will protect this material. So this is a comparing of some options of structures. The first, the picture in the left, my left, it's the first option, the reinforced concrete, the conventional reinforced concrete. We will put the rebars. We put the rebars in one direction on the main reinforcement, on the main loads necessity, but just on the one part of the concrete. The fiber concrete with small fibers, so you put these fibers on the entire piece surface. So we distribute better. It's a better distribution of the loads on the piece. It's a improve. But the textile concrete, as I said, we can put the textile just on we need on just when we need here the textile. So it's a very interesting. Which kind of textile we can use? the fiberglass, the glass fibers alkali resistance, the AR is the alkali resistance. The matrix, the cement matrix is very alkaline, so we need to have a fiber with alkaline resistance. So we can put the glass fiber or the carbon fibers. We have other options like the basalt fibers and other kind of fibers, but these two are more commercial options. The glass fibers are present the glass fibers present worse properties than the carbon fibers, but the glass fibers are cheaper. So the market nowadays is using more the glass fibers than the carbon fibers. So, but both of them are very interesting. They have higher modulus than the matrix, so the matrix crack, and then the fibers could work. So it's a very nice option. These some sets options for the market. First, the number A, it's a glass test tube with 3 and 5 centimeters of space. The second one is a carbon, is a better than the glass, but it's more expensive, and with 7 plus 7 the space, and the other one is 4 to 4. So the third one, the C test tube is better than B, and it's better than the A. So it's very easy, it's very flexible. We can adjust the test tubes with our necessity very, very easy. So just to compare, the first one is the reinforced steel, the regular reinforced steel that you use in our structures with 600 megapascal of tensile. This we use in our structures. Just to you see the glass our other test tubes. For example, the green one, the glass fiber with the resin styrene butadiene. It's not a very good resin, very not good test tube, and even though it's 1100 MPa, it means almost double of the reinforced steel, the regular reinforced steel. So it's much better, much more appropriate to our structures. If you change the resin to epoxy resin, the blue one, still with the glass fiber, 1300 MPa, much better. If you use the carbon fiber, look, 2000 MPa and 3200 MPa if you use the carbon fiber and epoxy resin, the best option that we have nowadays in a regular market. So much better than our conventional option of steel reinforced. So our cementitious matrix should have high fluidity, because we need to involve the test tube and without voids. We need to have a mesh opening bigger than 2 to 3 times the maximum grain size of the matrix. In the harder state, we have more than 50 MPa of compressive strength and 4 MPa of tensile strength. It means it's a very good matrix, This is the behavior in a tensile. You just see very fast the stage A. This is the matrix job, the modulus of elasticity of the matrix until the point A, when we have the first crack. So you can see in the picture the tensile will provide the strength. So when the tensile cracks, we use the matrix again and the tensile again. So it's a it's a very normal damage with no problem. This some curves of load and displacement, very interesting. We design the structure between the stage 1 and 2, because you need that point, the point A of when we pass the stage 1 to 2 is a critical stage, very interesting. So this is the bending behavior. Looking a lot of cracks appear very distributed, very well distributed. So it's very interesting, this behavior. As we have a much better material, look the steel. This publication, look the steel if 5.9 moment in this issue, with 80 millimeters of thickness, 80 millimeters to give us 5.9 of resistance. To comparing with test steel concretes, we can use a carbon test steel with 3 layers in 40 millimeters, or in 50 millimeter a basalt test steel with 2 layers. Look, we can reduce the thickness of the structure to 80/40, just to give you an example. We don't need a concrete cover because we don't have the corrosion. So some utilizations in the road, this material is widely used in Germany nowadays. So this is the Dresden University. They use this concrete, this stencil concrete for facades, panels, very interesting, with 1.3 meters and 2 meters, and with 30 millimeters of thickness. So very interesting, very nice structure. This walkway of 15.5 meters. So with carbon fibers, here is carbon fibers. The last example was glass fiber. Here is carbon fibers. Very interesting, a structural walkway. This is the cover of one built on in the Aachen University, so in German again. So this is some examples. We have very nice structures, very efficient, and this is a future concrete with low maintenance. Another one is the self-healing. The self-healing, we can self-healing the problems. You can fulfill the cracks with materials that the own concrete will produce. So we can have a biologic producer, we have a chemical option, we have some options to self-healing the cracks that will form in concrete. It's very natural for concrete structures to appear cracks. So we need this, and in these cracks, the bad agent could enter in concrete. So it's very important to seal, to close the ceilings to not have this option. We have these two mechanisms, the autogenic and autonomous. So the autogenic is when we use the cement or pozzolans with a chemical reactions to produce materials that will fill, that will occupy that space, that gap. So this is natural. You have this kind of autogenic mechanism in all of our concretes, but this is not very efficient. It's just for small cracks, very small cracks. It's not important for the real situations. The real situations, we need to use another materials to external materials to help the concrete to be the self-healing. So you can use chemical solutions, bacterial solutions, PSA. You can use materials with shape memory, materials to the use of vascular networks or nets, and you can use the crystallizing additives. This is the autogenic, as I said. The pozzolan reacts with the calcium hydroxide and reacts and formation the CSH. So this is, we know, this is already happens with the concrete, but we can use some autonomous, like the bacterial solutions. The bacteria will produce materials and will live, and the bacteria will work just when the crack opens and enter water. The water is very necessary for that reactions. So we can use the vascular nets to multiply the healing phenomena by the entire concrete. Now we can use these vascular nets for transport the self-regenerate agents. So, for example, this kind of solution, we will put the vascular nets in the entire surface of the concrete. So it's very efficient because you can have the vascular, we can have the agent, the self-healing agent in the entire part of the concrete. But the problem, it's very difficult to build this in a real structure. We use this just in lab situations, so this is not very used in the nowadays in the structures. The crystallizing additives is the best option nowadays. They are products, commercial products, that they have the self-healing agent. They have including the calcium in the product, so the agent could, the self-healing agent could react with this calcium and can form the crystalline products and close all the pores, all the cracks, all the problems that we have. It's the occurrence of cracking and water penetration. The water activates the crystalline catalyst. So we need the water. It's very important. We need the water. And this is, we can use also some chemical solutions inside the clay, for example, inside some expanded clay particles that you can put inside the concrete, and you can use this also. This is some applications in Brazil. We use the self-healing concrete in some museums here near the ocean, with a lot of chloride ions on the air. So we use this in very normal structures nowadays, but it will be it will improve their use in the next years, I'm sure. Some case studies here in Unicinos. We impregnate the expanded clay with sodium silicate. This is the process, and what you see, we can find these products, these self-healing products, less than 28 days after the crack. So it's very fast. In 20 days, you can feel the cracks of 160 and 135 micrometers. So you can feel these cracks just 1 month after the crack opens. This is some micro pictures to find the chemical compounds. Very interesting, very clear. Né? Some results with bacteria. The bacteria improve the compressive strength and decrease the water penetration depth. So it's very interesting. This is studies to check the current condition. The first two, very good condition, water immersion, water control, 100 of crack closure, 100. So, but if with no water, no water in in very great amount, like in a humidity chamber or air exposure, no crack closure. So we need water to give this reaction. We need water. So look the dimensions, the study of the dimensions with 0.3 millimeters. It's a very good crack to fill, to close. 0 days, 5 days, 15 days, 20 days, almost done. 20 days, very fast, almost done. But with 0.8, 20 days, almost nothing done. This is a problem. We cannot fool the big cracks. Until 0.5, it's okay. So this is our maximum crack seal is up to 0.5. This is a gap of the study nowadays. This is a good, very good crack, 0.5. I don't know if we need to seal cracks upper than this, but this is what we can do until now. We have to study more the feasibility of self-healing products over time, the adhesion of the self-curing product with the existing concrete. We don't know this kind of the quality of the self-healing product in 10 years, 20 years. This is studies that we are doing in this right time. The efficiency of different self-healing mechanisms in common concrete exposure environments. We need water to open these reactions. So thanks very much. Thanks for your attention. I have to hurry up very fast, but I think we could present these two very interesting concretes that will improve their use in the next years. Mainly now with this COVID effect that we need to build better structures with better service lives, with greater service lives, with low maintenance costs. So we try to explain this to you today. If you want to send me an email, this is my email, and I'm available to change experience and to answer some questions. So thanks very much, my friend Surendra. It's nice to hear about you again, and we are always available to change experience. Thanks very much. Bye bye.
Hello, everyone. My name is Alejandro Duran Herrera, and I want to take the opportunity to send you my best regards from Monterrey, Mexico. And at the same time, I want to thank the government of India, the Construction Industry Development Council, and to Dr. Surendra Manrekar for the invitation that I received to share with you some of my thinking about the role of concrete technology in the concrete construction industry. So for this purpose, I will share with you a presentation that I have prepared. So the subject of my presentation, as I say before, is the role of the concrete technology in the post-pandemic construction industry. To start the presentation, I want to share with you a definition for concrete technology that we have developed based on the definition of technology and concrete. Okay, so concrete technology, it is the set of theories, techniques, procedures, and instruments that are used to maximize quality assurance in the construction of a concrete work. Okay, so this definition clearly exhibits the elements that we have to put together to maximize quality assurance in the construction industry. And who will be in charge to put this together? The professional, the civil engineer or the architect. So in this regard, we think that education is very important. So at a bachelor level, at a college level, we think that all the civil engineering or architecture careers in the university should include a concrete technology program. These slides presents a summary of the subject covered in the program that we teach at UINL. That is basically focused in this theoretical part to teach students about concrete ingredients, the evaluation of concrete, durability, how to make a mixture design, how to proportion the mixture, how to produce concrete, what are the cares that we should take account to produce quality concrete, high quality concrete, concrete handling, and concrete curing. Also, we cover non-destructive testing, everything about cores, how to obtain them, how to analyze the results, how to report the results, pathology of concrete, what are the sickness that the concrete can suffer, and special concretes. This program is complemented by a 7-session laboratory program that is oriented to facilitate the student lab sessions, to put a program of lab sessions for the student to develop skills, okay? Skills on how to produce concrete, how to evaluate the performance of concrete in fresh stage, and how to evaluate the performance in hardened stage. Okay, so basically what our objective is to share with the student the state of the art and knowledge, an appropriate state of the art and knowledge for a bachelor degree students, and as well as skills that together will give them the necessary competencies to support the activities on the job site. Okay, but in our opinion, the information that a student at undergraduate level get during his career during his stay in the university is not enough. Is not enough. Even though the some of the inspectors have a university diploma on civil engineering or architecture, we can find these problems in the construction site. So under this scenario, we think that the professional require complementary knowledge that won't be available in the university. Part of it can be available, but most of it can be found in several technical associations. One of the complementary programs that we think it could be a very good complement for the knowledge of professionals that will be involved in the construction industry are the certification programs offered by the American Concrete Institute. For sure, there are some other institutions, some other institutes or organizations that could offer similar programs to complement the knowledge and the skills of the professionals, of the young professionals. In the case of ACI, at the moment they have 28 international certification programs. 13 are oriented to testing the concrete materials or the concrete by itself. 6 are oriented to inspection programs, and 9 are oriented to construction specialist programs. Why someone should get certified? Someone who is involved in the concrete construction industry. The trend is that more and more companies, construction companies, government agencies, among others, request that engineers, architects, designers have a certification that supports them, as well as technicians who control the quality of concrete and inspectors, who ensure the quality of the construction to have better quality work. So basically, a certification is a knowledge that support and give the whole team a higher level of confidence that this individual could contribute to improve quality in concrete construction. Why it is important to have, or what are the benefits that we can get? Why a professional like a civil engineer or an architect should have a certification as a technician? If we make a comparison with the procedures followed in a hospital or a clinic, we see that the vital signs normally are monitored or measured by a nurse. But when a nurse is not available, the doctor can take those measures because he knows how to do it. So it's important in the medicine, in the medical area, that the doctors knows how to do that. It's basic knowledge for the doctors. So in the same way, knowing how to measure the vital signs of concrete is a very important issue for the concrete construction industry. Not only because they will know how to test how to perform the test, is because the professional will be more sensitive about the importance of these properties and how they influence the performance of hardened concrete. Okay. So programs that I recommend to complement the training of a professional in the concrete construction industry, there are one that will allow them to learn how to test concrete in fresh stage, the basic testing of concrete in fresh stage, is the concrete field testing technician. This is the most popular program in ACI. And another program is a program that just appeared last year, is the self-consolidating concrete testing technician. Why? Because more often we see self-compacting concrete in the projects, okay? And it's very important that the professional knows how important is to test this concrete in fresh stage. By the way, in these concretes, the most important properties are in fresh stage, because in hardened stage, the performance is similar to the one presented by a conventional concrete. So it's very important to be aware about the influence of the high flowability in the pouring of concrete and the stability of concrete to avoid segregation. So even though this course is mainly focused for technician, it will give a very good sensitivity to the civil engineer or to the architect. Another course, of course, is a concrete construction special inspector. This course require, if you want to have this certification, it requires that the individual have first the concrete field testing technician certification. Another way to contribute in the improvement of knowledge of young engineers is to promote summer stages. Summer stages in the industry, summer stages in research centers, summer stages in universities. In this photograph, you can see colleagues from the University of Sherbrooke in Canada, part of our group in UANL, and many students who used to visit us during the summer for a research stay of 1 month or 2 months. And it's very important for them because they learn about concrete technology. It's a subject that is not well covered in most of the universities. So they learn about concrete technology, and they, with what they learn, they can have a clear idea if they want to go, if they want to pursue a graduate program on construction material or concrete technology. Well, to analyze how to show how the importance of how the knowledge is advancing, okay? To show you how the knowledge is advancing and to make clear how also in concrete and construction the knowledge is advancing, I want to make an analogy with the with a childbirth. Okay, if you think about it, 3 or 4 generations ago, there were no medical doctors for the majority of the population to help them during the childbirth, to help the lady during the childbirth. Okay, and so on that time, a person called midwife was the one that assists the woman in a childbirth. Okay, but as the knowledge advances, a medical doctor starts to support the woman in the childbirth. But after the advancement of knowledge, you know, the knowledge is always advancing. They create in the medical area, they create a new specialty that is gynecologist, okay, that is in charge of the lady, okay. But as time passes, they see that Gynecologists can attend the lady, but who will attend the baby? So they have to include another doctor with a specialty on pediatrics. Okay, and actually that doctor that participate in a childbirth is not a pediatric. It doesn't have a specialty. It has a specialty on pediatric, but it has another subspecialty on neonatologist. So that's just to give you an idea of how the knowledge have forced the medical segment to create new specialties. So neonatologists in the health science is the subspecialty of pediatrics that cares for the condition of the newborn neonate during the first 28 days of life. Okay, because what he should take care, he should take care about the diseases that the neonate can present during the childbirth, like anemia, like breathing problems, like benign skin disorders. Okay, so in the same way, we have to be aware of the problems that concrete can present, but when it's in fresh stage, because it's when we can make some efforts to correct those problems. Okay, so what are the problems that the concrete can present? Bad planning, shrinkage problems, dosage errors, absence of or deficiencies in curing, casting in extreme climates, casting massive elements, pure compaction, segregation, unskilled supervision. So all these aspects can contribute in a bad performance of concrete, but those are mainly focused to newborn concrete. Okay, is when we can make something to solve them. Okay, so the team, the human, technical, professional team that participate in these two cases. In the case of the childbirth, an instrumental nurse, a gynecologist, an anesthesiologist, a neonatologist, and in the case of concrete construction, masons, laborers, structural designer, architect, contractor, project managers, concrete technologists, laboratory technicians, construction inspectors. It's common that in concrete projects, the structural designers take care of aspects related with concrete technology. Okay, but now in all this stuff, we have to start to consider a concrete technologist. Okay, so a proposed definition for concrete neonatologist is the following. In material sciences, it is the sub-specialty of concrete technology which is in charge of attending the diseases, illness of freshly cast concrete, the neonate, during the first 72 hours, the first 36 being the most critical. Okay. Another experience that I want to share with you is an analogy that I made when in our school we have a colleague who came to make us a presentation of a new software that his company developed to facilitate the ordering of concrete mixtures. Okay, so it's a big company and they make a software in which you give as an input information, all the information that you require to design mixtures, like the maximum size of aggregate, the environmental conditions where the concrete will be in service, the geometrical aspects of the construction that we want to build. So all that information, the same information that the ACI 211 requires during the design of a concrete mixture, So it was the same information that this software required. And at the end of the presentation, he tell us, so the software give us a custom custom made suit, okay, and after his comment, it comes to our mind that truly the software what it gives is just the cloth to make the suit, not the whole suit. Okay, so imagine in the same sense, imagine that you arrive at a hospital with one of your very sick relatives who require urgent medical attention, and that you, due to your economic capacity, had no restrictions to pay what is required. What doctor would you trust your family member with? We have a newly graduated doctor, and we have an experienced and prestigious doctor. Of course that you will show the experienced and prestigious doctor, even though he charged 3 times that the new graduated doctor, because you don't have restrictions to pay. Okay, so it's the same thing in the concrete construction industry. Why we put the concrete under the supervision of a newly graduated architect or engineer? The new concrete deserves the inspection of experienced and prestigious engineer or architect. Okay, and why is this valuable? Because the experience that he have gained during time. Okay, it's like this lady Liu Yang, the China's first female astronaut. Imagine how much she had to train. How many ladies also wanted to be the first astronaut, the first lady that go to the space from China, but he was the only one. Okay, imagine how much she trained, what she had to do. So she was very well trained. So that's what the concrete deserves in practice, well-trained professionals. Okay, so I was telling you the experience that we had with the presentation of our colleague, and he told us that the software give us a custom suit made, and we told him no. The software just give us the cloth, okay, but the quality of the suit depends on the hands that will make the suit. Okay, so in concrete construction, okay, the cloth is the concrete mixture, and the ones that make the suit are those who handle the concrete. Okay, those who place the concrete, those who compact the concrete, those who cure the concrete, those who inspect the concrete. Okay, so those are the ones that are responsible for the quality of the concrete in the structure. Okay. So what a concrete technology does: design of concrete mixture, concrete and mixture specialty, concrete construction inspector, production of precast elements, design of reinforced concrete structures, writing of the tailored specification, structural and geometric integrity evaluations, quality assurance and verification, durability indexes, non-destructive testing, pathology, repair and rehabilitation, special concretes, and research and development and innovation. Mentioned 14 items. Okay, that's what a concrete technology can do. Okay, so the presence, the importance of a concrete technology in the whole process is very important. So how to improve sustainability in concrete construction? As I say before, education. Education, and the government agencies should be committed to quality. Also, planning should be based on quality assurance. We should write clear and detailed specifications. Okay, we should use appropriate concrete mixtures. we should involve competent and certified professional and technical staff, like laboratories also for testing. And we need the commitment of all those involved to incorporate the state-of-the-art knowledge in their practices. So education of engineers, of architects, of technicians. And we are very lucky because actually we have a lot of sources that can give us on real time, very fast, state-of-the-art knowledge about concrete, like the one cited here in the left lower, in the right lower corner. Okay, thank you very much for your attention, and I take the opportunity to invite you to join us next year in Mérida, Yucatan. We will have the 75 RILEM Annual Week from August 29 to September 3rd. Thank you very much.
The title of my top presentation is on strategies for enhancing resiliency of modern concrete structures under fire hazard. The buzzwords here are resiliency, obviously, modern concrete structures, and fire hazard. So those three are the buzzwords here. So what I'm going to do today is to just give you some background information to the overall importance of fire safety, specifically mostly in buildings, but in infrastructure, critical infrastructure. Then I'm going to also look at the resiliency, why resiliency is much more important in the current or the modern concrete structures as opposed to structures, 30 years ago. I'm going to look into that, and I will illustrate, in addition to that, some of the fire statistics, we call it. The title of my top presentation is on strategies for enhancing resiliency of modern concrete structures under fire hazard. The buzzwords here are resiliency, obviously, modern concrete structures, and fire hazard. So those three are the buzzwords here. So what I'm going to do today is to just give you some background information to the overall importance of fire safety, specifically mostly in buildings, but in infrastructure, critical infrastructure. Then I'm going to also look at the resiliency, why resiliency is much more important in the current or the modern concrete structures as opposed to structures, 30 years ago. I'm going to look into that, and I will illustrate, in addition to that, some of the fire statistics, we call it, to see how the magnitude of the fire problem itself around the world. After that, I will move on to a brief mention of various experimental and numerical studies we have carried out to develop techniques and technologies to overcome the fire problems with respect to especially the new concretes. I'm going to discuss some of the critical parameters, and finally at the end, I'm going to quickly point out some of the innovative strategies that can be implemented even in new concretes and new structures to overcome not only the fire problem, but also how we can enhance resiliency. Okay. So as we all know, concrete is the most widely used construction material in most countries, or if not in all countries around the world. And there are a number of advantages. A lot of times, all these advantages students are taught very well, even in their early concrete courses. But one of them, which is conveniently forgotten, is it used to be, it was started because with timber or steel has a lot of significant problems with fire resistance. I will define what fire resistance is. So one of the best materials from fire safety point of view is concrete for structural members. That's why it's widely used as well. There has been significant research and development activity with respect to concrete, especially from the material point of view. And this has led to a lot of new concretes, such as high performance concretes, they call it, or high strength concretes, ultra high performance concrete, fiber reinforced concrete. And much of these concretes are provides very good strength, stiffness, durability, sustainability, you name it, much of the needed properties. However, with the recent concretes, one of the problems is fire, which we will come to that in a second. Before that, fire is a major hazard in the built infrastructure, and especially in buildings because of the life safety requirements. Fire poses a significant hazard and threat to the built environment. And conventional concretes usually used to have much higher mass and much higher fire resistance, but same is not true with the new types of concrete, which I will show you quickly. Now, the emerging trend over the last 30, 40 years, in most parts of the world, is to resiliency is the key buzzword for critical infrastructure. Okay, so this includes buildings, bridges, tunnels, whichever we classify them as critical especially. So concrete structures exhibit very high levels of resiliency in terms of safety, robustness, disaster resiliency of the different materials. However, today in the current way of doing things, we evaluate this resiliency or check for this resiliency in critical infrastructure, especially under blast, earthquake, impact, but we don't do it even the basic things for under fire hazard. It's all based on the prescriptive approaches developed 40, 50 years ago, which are present in the codes and standards. It's not in any country, even in the US, for example. These are all tests based on single test done on columns at Underwriter Laboratories or NRC Canada. Still, we continue to use those provisions which are not really applicable for the modern construction. So fire resistance and basically, since we don't evaluate this resiliency specifically under fire hazard, modern concrete structures are susceptible to problems, especially under fire. Now, I don't want to spend too much time. Fire, as you all know, is a significant hazard in terms of statistics, as I mentioned to you, not only for people, but also for infrastructure or structures. This is some of the statistics. In the US, there were more than 1.3 million fires and led to more than $50 billion of damage in 2017, almost about 2% of our GDP. Now, when fire happens, remember it can start if something goes out of control. Either lightning can start a fire on a bridge, for example, or something going out of control in kitchen can start an accidental fire, electric short circuit. That's primary event. Also, fire can start following a blast happening somewhere or an impact. A truck hits a bridge, that impact doesn't do much damage. The bridge is designed for that, but it's not designed for the fire which follows that. 9/11, the 9/11 buildings were designed to account for the impact loading of a smaller aircraft, not that aircraft. I was part of that investigation, but when we looked at it, it was never designed to account for the fires that ensued the impact loading. So similarly, even floods can lead into fires, as it happened in New Jersey in 2012 Hurricane Sandy. So as a secondary event, fire can do much more damage than the primary event itself. Now, it's impossible to prevent all the fires, okay? And so proper measures are to be put in place, such as sprinklers, heat detectors. You put in a lot of things, heat detectors, smoke detectors, exit paths. These are all called active systems. But one additional thing we need is the structure has to stand up till that fire can be fought or fire can be extinguished. And this requires your structure to stand up. For example, in 9/11 buildings, right? The buildings, for example, collapsed not because of the plane sitting. It would have been standing today. That's the conclusion of the official report. It collapsed basically because of the huge fires which ensued after the impact loading. Now, in order to do this, and it's very important from life safety, property protection, and everything. So if you have higher fire resistance, you can have higher resiliency in the structure itself. Now, there are a number of fires around the world. Now, these are some of the recent fires in the United States. For example, the damages which happened in November 2018 California wildfires is more than $3 billion. These for structures. and more than $26 billion of insurance was paid out because of that. This was not major structures because it was in the outside the towns, but there was some kind of damage to some structures as well. Now, in addition to that, 9/11, obviously, you all know much more about this. There was bridge fires in the United States, tunnel fires, for example, warehouse fires. So fires do happen. Oakland warehouse, where 36 people died again in Oakland, California. So and in this case also, there was significant structural damage. Now, I'll just illustrate you, there is not much time in today's presentation, but quickly illustrate you how things can go wrong. This is an I-85 bridge outside of Georgia, Atlanta, Georgia, Atlanta Airport. And on a fine day, on a fine evening on 30th of a spring day, or about spring has started, on 2017, what happened was they put in underneath the bridge for repair, drainage repair, lot of pipes, polyvinyl PVC pipes, polyvinyl chloride pipes, and then they left it and went because they wanted to start the work later April or May. All these pipes were here. A homeless person, it was a cold evening, so he comes in and sets fires to all the rubble or paper which was around it, and then that goes out of control and goes into the pipes, and huge fire starts. And look at this fire, which was fire department because it was closer to the city, Atlanta. So lot of fire engines came, or firefighting trucks came, couldn't be fought. They had to withdraw because of significant spalling. You can see this here, rebars completely exposed, spans of the bridge collapses. You won't believe how much damage. Delta had to cancel about 1,000 flights over the next 3 days or more because nobody could get to work. All the flight, that's the hub of Delta, where it's world's largest airport, basically. So I think that's the kind of damage that can happen, and it took weeks for the bridge to be rebuilt. There are a number of buildings. I can name, hundreds of buildings which were on fire in the last 5 years. Important buildings is Tehran, Pasco building, 17-story building collapses. Number of firefighters died as well as people died. Grenfell Tower, you know that what happened in Grenfell, concrete building. The first one was a steel building. I was part of the investigation at Delft University of Architecture, university building, 13-story building which collapsed because fire started due to an electric short circuit in a coffee kettle, which was not turned out, and it starts. So there are a number of fires in the building, so it's a real hazard which we are looking at. If you look at the world statistics, as you can see this here, India especially, for example, has the worst fire record. Nearly 24,000 people die every year because of the fire incidents. May not be due to structural damage, but fire as a whole thing has to be considered as an hazard. A lot of times smoke is the one which kills more people than anything to do with the structure itself. Now, how does the current codes address this? Current codes address this by putting a lot of fire protection measures, and this depends on the height of the building, what type of occupancy. For example, if you have buildings which have old age people or hospitals, then obviously you need to provide higher fire resistance, or it should stay longer than an office building, for example. So these are put in place in the building codes, including in India, and every other country has this. So without that, you cannot get permit to have the building. And what is the fire safety strategies? We put in a lot of measures, as I said, sprinklers. Fire comes out, it should be put out by sprinklers automatically. Most buildings in the United States, new buildings are sprinklered, but often sprinklers are not effective. So then people has to be sent out. Then you have fire to be contained to the source of the origin in one compartment or one room or two rooms. That's done through barriers, or your structure has to stand up till the fire is fought. This is what is called as the fire resistance. And depending on the height, depending on the occupancy type, you need 1 hour, 2 hours, 3 hours, or 4 hours. Under so-called standard fire, the building has to stand up. Okay? So I will skip this slide. So fire grows something like this. Just remember this. Nothing happens to the structure here. I'm talking more about structure. People should get out at this time. But for structure, this is the part where structural fire resistance comes into play. So typically you need 2 to 3 hours of resistance in structure not to collapse under fire. Okay, so this fire resistance depends on a number of factors, and including what kind of a fire you have, what's the type of materials you have, whether it's a concrete, steel, or you can see that this is loss of strength with temperature. Different materials lose strength at different temperatures. So all this has to be accounted for. Now, current provisions, if you take conventional concretes, is really very prescriptive. As I said, much of this is developed based on 60s and 70 concrete types and technologies. And as you can see, all you need to do is power certain cover thickness to the rebars, because steel is a weaker part in this slab, or in this one as well. As long as you have sufficient cover thickness to the rebar, you have achieved certain fire rating. More fire rating or more fire resistance you typically get with a higher cover thickness. Now, American codes are so prescriptive, there is no other way of engineering the system right now. For 1 hour, as long as your dimensions is 8 inches minimum, that's 200 millimeters, you get 1 hour in a column cross section, and you need to provide 1 inch concrete cover for getting 1 hour rating. For 1.5 inch, if you provide concrete cover, then as long as your minimum dimension is 9 inches, then you are going to get 1.5 hours rating, and so on. As simple as that, which is not realistic. Now, what about Euro codes? Very much similar. Look at this. In one table, they cover beams, columns, slabs, and walls, and same approach as this, very prescriptive. Now, I have to move on quickly because of the time. So modern structures are significant problems because they are typically taller as opposed to 70s, 40s, 50s structures, and they are leaner. I will show you that, and they are made of new types of materials. Newer the materials, lower is the fire performance, and we have increased demand on the modern structures because we use all this nonlinear analysis and all this and make the structure very slim. Okay, so the current codes, typically, if you take the modern structure, they have lower fire resistance compared to the equivalent structure of yesteryears. Now look at this modern slabs, how different they are. If you take solid slab, hollow core slab. If you take a column, look at this, how small we are building with higher strength concrete. Same thing, we are using this type of shapes. Similarly, our concretes have much more problems because we increase the concrete strengths and it comes with lower permeability. It's susceptible to two things. One is because the strength of the newer concrete, see this red line, this is how the strength drops with temperature. Look at the normal strength conventional concrete, slowly drops. So this is the major problem. The second bigger problem is the occurrence of so-called fire-induced fall. Look at a concrete column, 6 hours in a fire, which I tested, nothing happens, 16-inch column. This is typical column used in Chicago. And look at the column, high strength concrete column in 19 minutes. This was done for Portland Cement Association and Construction Technology Laboratories. I did these tests at NRC, about 15 columns were tested for them, in addition to a number of other things. So we developed a lot of guidelines. So this falling, basically why it happens is buildup of when it's exposed to fire, this has lower permeability, moisture becomes vapor, it can easily get out here, 10 to the power of minus 16 is the permeability. When you reduce it by 100 to 1000 times to 10 to the power of 18, that pore pressure converts into the tensile strength and pushes this out. So boom, 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 throughout this fire scenario, you will have spalling. And this spalling can reduce fire resistance significantly. We did number of tests. We did the material property test. Over 30 years of my research is focused on this, first at NRC Canada and then at Michigan State University now. And we developed about 15 PhDs so far have graduated on this related topics. So we have developed advanced analysis models, and recent work has been to develop much more guidelines as well as with ultra-high performance concrete. See, the concrete, as I said before, current codes say only cover thickness is the issue, the size of the member, but it is affected by so many factors. Strength of concrete, reinforcement layout, density of concrete, type of aggregate, whether you're using limestone or quartz. So there's a number of things. As you can see, higher strength concretes, conventional concretes, but if you add fibers, you can significantly minimize this falling which is happening. Okay, so another thing is if you bend the ties, it enhances fire resistance significantly. Okay, so bending the ties at 135 degrees, this we did for PCA and this is in American courts right now. You can reduce falling significantly even with higher strength concretes. Then concrete, when it is subjected to a column, for example, when it is subjected to concentric loading, under fire, you have hazardous falling happening in different sides. So that means your concentrically loaded column becomes eccentrically loaded, either due to development of thermal gradients when only one side, two side, or three sides exposed to fire. So a three side exposed to fire, two adjacent sides exposed to fire can be much lower fire resistance than a four side which is exposed to fire. This can cause significant problems in real life. Okay, so let me skip this. How can you overcome this? If you can add polypropylene fibers, these fibers are 0.1 to 0.2% by mass, by volume. So they melt at early temperatures of 160 degrees and increases the permeability or create pores where the pore pressure can easily be dissipated. If you add steel fibers, it increases the tensile strength and it significantly overcomes the pore pressure. It withstands the pore pressure so that there is very less falling. Okay, you can do few other things. So look at the columns we tested. These are all tested in the lab. Plain concrete, polypropylene fibers, no spalling, steel fibers, very little spalling, as well as hybrid fibers. You can change the configuration. If you provide the ties like this, it does wonders. It increases the fire resistance. Instead of failing this column in fire 1.5 hours, it can go up to 4 hours by just bending these ties or by providing cross ties. Okay, and there are very minor other things like changing the aggregate and stuff. I'm not going to get into this. The last point I want to make is you have to engineer it and you have to use advanced analysis approaches wherein at a system level, you need to account the realistic fire which can happen in a structure, realistic material properties, if it is high strength concrete, high performance concrete, ultra high performance concrete, whatever it is. Then you have to account for this falling and other things which are very complicated even at this stage. These are all PhD topics, for example. There is very little data. And then you can carry out the analysis, first finding out the fire scenario. Then you find out the temperatures. And then you calculate the structural response. And then include all your spalling, creep, bond, degradation. Everything changes with temperature. That's where the complexity gets in. Okay. So we have done a lot of this. It's published in number of journal papers. But let me conclude here. So resiliency of structures should be one of the critical conditions or critical considerations under fire hazard, especially with modern concretes construction. There are very few problems with respect to conventional concretes, but same cannot be said about the modern concretes. High strength concrete structural members are ultra high performance concretes. They exhibit lower performance as compared to conventional concretes, as well as significant spalling problems. So you have to have engineered the system through advanced analysis. We call it performance-based design, but you have to use advanced calculation models so that you can develop unique strategies for overcoming this. Okay, so as I showed you, simple modifications such as straight configuration of fibers can help in overcoming this problem. So this is one of the recent articles in ACI, very general article in Concrete International. So there are a number of journal papers associated with this. And finally, I want to say this, there are very limited books in the fire engineering area. This is one of our recent books. It addresses not only concrete structures, steel, wood, timber, masonry, FRP, all structures, how to design for fire. This is a new textbook which just came out from McGrail last month. And thank you.
Good morning, everyone. Good morning, everyone. My name is Pedro Garcés. I am member of Civil Engineering at Alicante University in Spain. It is wonderful to be here presenting at the International Conference on Reviving Construction Industry in Post-COVID World. First of all, I would like to express a word thanks to the organization, in particular to Dr. Surendra Rekar for his kind invitation. Thank you very much. My presentation is entitled Conductive Multifunctional Concrete. It is widely known that the main function of concrete is its structural function. On the other hand, concrete is a bad conductor of electricity, it's a dielectric. However, the addition of a conductive carbonaceous material such as graphite products, carbon fibers, carbon nanofibers, carbon nanotubes, transforms the resulting mixture into a conductive materials. And this gives the possibility of using this new material for other function different from the structural one. So it can be considered a multifunctional materials. Possible applications include sensing function, heating and de-icing function, and electrochemical application. Here we can observe some pictures of cement-based materials and some carbon fibers and carbon nanofibers. In first place, let me comment on the first function, that is the sensing function, or the ability of a structural material for detecting its own deformation when subjected to some external static or vibrating load. This means that we are in the presence of a very promising and interesting material if we want to plan an intelligent structure. Specific applications include structural vibration control, traffic monitoring, building safety, AC optimization, and structural service monitoring. Sensing function is based on the change in the electrical resistance in concrete when some stress is applied to it, and it is quantified by the gauge factor, that is the ratio of fractional change in resistance divided by the fractional change in the formation. Due to the change in dimension, length of sections not being significant, then the change in resistance must be due to the resistivity change in this material, and that is a material intrinsic property. Let me explain this figure. The material strain sensing capacity is defined as the response on the volumetric electrical resistivity, proportional and reversible, and due to its strain state. If a longitudinal compressive stress is applied, the electrical resistance in that direction is reduced. The contact between fibers themselves and fibers and paste becomes closer and closer, and consequently the contact resistance also changes. And vice versa, the material recovers the initial state when the stress is removed. Both effects are reversible in the material's elastic range. Therefore, the electrical resistance returns to its initial value once the load is removed. It is an important figure. You can observe that we are working within the elastic regime because stress and strain are reversible. When the load is initiated and the stress increases, the deformation also increases, shown in blue. And as a consequence, a proportional decreasing of the electrical resistance can be observed, shown in yellow. After this first loading step, the load is returned to zero, and so stress and deformation recover the initial value, as well as the electrical resistance or electrical resistivity. It is important to calibrate each and every sensor previously to its application. To do so, the slope of the variation of resistivity versus deformation gives us the so-called gauge factor, which controls the accuracy of the measurement. In order to know the limits of the carbonaceous additions, it is important to know the value of the property called percolation threshold. Percolation threshold comes when there are enough fiber density to establish a continuous path of electrical current. For a given slenderness, increased carbon fiber content decreases the resistivity. Once the percolation threshold is reached, it makes no sense to increase the percentage of carbon fiber because the resistivity is not any more significantly changed. On the other hand, as the fiber aspect ratio increased, percolation was achieved at lower carbon fibers content. This graph validates the sensing function. This figure shows the result of the test still in the elastic range, which loads were increased and maintained for 60 seconds before the next load step and then symmetrically decrease. Again, a very good response was observed, even in constant. In blue, the strain monitored with a strain gauge, and in red, the resistivity of the specimen. Once more, proportionality between electrical and mechanical parameters as well as reversibility can be observed. This is another important graph. In this slide, the response for loads surpassing the material elastic limit is presented. That is, the material is behaving in the plastic state, and the strain is not longer proportional to the stress. The initial strain is not recoverable with the initial load. Similar behavior can be observed with electrical resistant chains, probably because of the decoupling and breaking of carbon fiber in cement matrix. Therefore, that means that damage can be controlled while monitoring the electrical behavior of the sensor. Next, we decided to check the viability of attaching a small specimen of conductive cement paste on the surface of the standard concrete specimen, not conductive. On the left hand, we can observe that two different gauges were used, one of them attached to the concrete specimen and the other on the conductive specimen. That way, we could control the strain of both elements. On the right side, we can observe the electrical resistance change in the small control specimen and the strain in the concrete. So by controlling the resistance of the attached sensor, the deformation of the standard concrete specimen is monitored. After this study with sensor attached to a small concrete specimen, we decided to attach them to a regular site reinforced concrete beam, and 28 cement composite sensors were prepared. Two different tests were made depending on the magnitude of the maximum strain and stress in the reinforced concrete. The first one remaining the beam in the elastic regime, and the second one producing cracking and final breaking of the beam. This figure shows the results of the one test with different loads and unload status for an on-site fabricated carbon sensor on the upper side, complicit phase of the beam. In the red sensor beam strain in micro deformation, in blue the electrical resistance of the sensor, both versus time. Very good response was observed again. Our final goal is to reserve conductive cement-based materials which are capable of being strain sensors and can be applied to real structure elements for structural heat monitoring. Our future research effort focused on a measurement system that can be computerized and a control algorithm implemented in a real structure in order to have real-time feedback of strain that can be used for structural health monitoring. The next function is heating and de-icing function. Many methods and techniques have been investigated for pavement anti-icing and de-icing, as snow and ice on roads causes enormous losses in human lives, infrastructure and materials. The mechanical snow removal technique is the most used, but it it is an intensive, expensive, and time-consuming labor. Furthermore, not all the snow is completely cleaned from the driveway by snow plows, leaving a small layer to be eliminated. Many methods currently used to remove ice from roads are based on the use of chemicals. Most of them are harmful to both reinforced concrete and steel structure, viaducts, tunnels, airport runways, and for the environment. Compared to these methods discussed, there is the possibility of using heating system of conductive concrete layers. Addition of a conductive carbonation material to cement-based material allows to reduce the electrical resistance of the resulting material, so that application of the potential difference produce an electrical current by Joule effect, which is able to quickly melt the ice deposited, so it can be considered as a curative process, or to prevent its formation from the freezing of the mixture on the roadway, so it can be considered a preventive process. As it is well known, Joule effect is based on the thermal effect produced by electrical current through conductive base. Well, heating test consisted of applying a constant voltage between two ends of sides of each specimen. Cement paste with different carbon addition were prepared in order to study their heating capacity. Different tests were carried out for each sample, varying the applied voltage. In this figure, the average temperature for all PT100 sensor and power supplied versus time is shown. In this figure, we can observe that when the power is turned off, yellow line, then the temperature starting from around 24 Celsius degrees in red line increases slightly to reach a constant value around 42 Celsius degrees. Then, once the power is turned off, the temperature decreases up to the room temperature. We have also developed other tests reaching lower and much higher temperatures, even up to 140 Celsius degrees, of course, depending on the composite and the power applied. In any case, we are only interested in action against icing. In this stage, we considered to model, to validate the mechanism of heating and to check that heating is produced by Joule effect. The process will be divided into two stages for which the mathematical equation that govern them will be defined, heating and cooling. The first stage is the stage of heating produced by the application of the electrical current. The sample is heated by Joule effect in a non-steady process, and changes of thermal energy in the sample are due to the applied electrical power minus the rate of the energy lost by cooling, which can be calculated with the Newton's law of cooling. In the second stage, the time lapse is long enough, so it implies a steady state and a constant temperature. On the other hand, the electric power supplied, in this case, is equal to the energy lost. Finally, the stage 3 is the stage of cooling. The sample is not electrically heated. In this case, thermal energy of the sample is released to the outside. In this figure, we can observe the experimental results and the calculated results. In any case, the simplified model is an excellent tool to study the influence of the different parameters in the heating of the samples. Practical application is based on the feasibility of the use of cement-based material studied to control ice layers in transportation infrastructure. A thick layer of ice was added on both sides of the samples, and it is observed a grid increase in the ice melting rate with the application of electrical power. In this figure, we can observe the evolution of the surface temperature of the specimen in one of these tests by thermographic imaging. Well, let us imagine a real situation in which an airport runway suffering a snowstorm, therefore with a temperature under minus 10 degrees, and snow plows are removing the snow, and indeed the airport is suffering a real problem of flight management. And let us imagine again that the upper layer of concrete of airport runway is a conductive layer, and then a power supply is turned on. As a consequence, the average temperature of the surface could be increased above 0 degrees. Well, we tried to transform this idea in experimental research. The specimen was introduced into the freezer, being the temperature of the freezer in minus 15 degrees. Then the power supply was switched on, and as a consequence, the temperature of the surface of our specimen increased, reaching temperature above of 0 Celsius degrees. Many hours later, we switch off the power supply, and as a consequence, the temperature of the specimen reached the same temperature of the ambient. This is, without doubt, a curative test. And now let us imagine an airport in a real situation of fine weather, and suddenly the same snowstorm as before. Temperature is decreasing rapidly, reaching an average temperature of the surface of 5 Celsius degrees. And in this case, the experimental test that we call prevention test, the specimen at room temperature were introduced in the freezer. When they reach approximately 5 Celsius degrees, power source was connected at a fixed voltage. After steady temperature was reached, then power source were turned off. Well, the main goal of this function is the development of the heating and the icing function in pavements such as airport runways. Instead of heating the whole depth of an airport runway slab, the heating is applied to a conductive layer with a formulation compatible with the slab concrete and oily some centimeters deep. Next, I am going to present you the electrochemical application function. The principal objective of this function is to study the viability of the application of a conductive cement paste as an anode in the application of these electrochemical techniques, such as electrochemical chloride extraction and cathodic protection. The corrosion processes of the steel reinforcements embedded in concrete are the main pathology affecting the durability of reinforced concrete structure. It is well known. Corrosion starts as a consequence of the destruction of the passive film, which prevents the steel to corrode. The main causes are the carbonation of the concrete cover in urban environments, or the presence of certain amount of aggressive ions such as chlorides in seaside environments, or due to the use of the icing salts. European standard limits its content to 0.4% of cement mass. When corrosion occurs, it is necessary to repair the structure if we want to use it for more time. Otherwise, there is a high risk of collapse. The traditional method for a structure contaminated by chloride is the replacement of the structural elements affected by the corrosion process. However, There exist some new methods such as cathodic protection, electrochemical realkalization, or electrochemical